Good morning, everyone. Welcome to the fourth day of the second school of Destini on smart data and systems of deep insight. Thank you once again for your attendance. Just to remind you, the school is being live streamed on Facebook page and will be uploaded on YouTube later on. Our first presenter for today is Professor Aloisio from the Department of Electrical Engineering, Computer Engineering and Informatics of the Frederick University. She is going to present to us the topic computer graphics and animation. Professor, when you feel ready, you can start with your presentation.
Okay, thank you very much. Okay, as you said, I'm going to be talking about computer graphics, in particular animation, which is my major research topic. I'm going to go a bit of historically of how all these things started and what are the stages that we are currently at, and especially in terms of research-wise, where do we direct ourselves. So basically, first of all, let me just try to give a kind of small definition of what is computer graphics. Basically, a graphical image, a digital representation of non-text information. So we're talking kind of anthropomorphic figures. We're talking about, let's say, animals or even items. I mean, without having, let's say, a live representation. However, this thing is comprised of three different, I would say, steps, entities, how you want to call it, elements. So basically, the first thing that you have to do in order to apply correct graphics, you have to do geometric modeling. I mean, this is basically the mathematical representation of an object's geometry using software. The geometric model contains description of the model object's shape. So basically here we are talking about curves like B-splines or any geometric model that, let's say, the animator could decide to use in order to construct quite acceptable, I would say, I mean, realistic models. Now, as a second stage, we are considering this as a second stage, you could be talking about animation. So I even put the asterisks there just to show that this is my research interest. Okay, animation, it used to be a subclass of computer graphics. I mean, in the oldest days, whenever I used to get a book on computer graphics, there was always at least one chapter, normally the last, referring to animation. Nowadays, I think this has changed dramatically, I would say, whereby we are at the stage when we refer to computer graphics, we by default refer to animation, and in a sense, about computer animation. So basically, this gives life to your animation sprite, to your anthropomorphic figure, the animal, whatever you're trying to depict. I will come back to animation. I mean, this is what I will be talking a lot today. And then towards the last step, the last stage, we have the rendering. So rendering, it's the image synthesis, is generating photorealistic, acceptable results. I normally used to say to my students, for example, this is the final touch. So without rendering, not a lot of things are acceptable, or they are like we are used to in our human eye, for example, to see, to visualize, to, let's say, accept. So it's normally the last step in the graphics pipeline, giving models and animation their final appearance. A renderer, which is, I need to admit, it's a computational expensive software. It's carefully engineered program whereby it deals with, let's say, the light physics, correct light physics, the visual perception, it deals with mathematics, software development. But the importance of this is that this rendering has to be happening in real time. So basically here we are talking about, and this is something that I think nobody could object, that we are really interested about real time and realism. I mean, these are the two major concerns when we are dealing with computer animation. So the next thing I wanted to, let's say, define what is computer animation. I mean, I know there exist so many different definitions that somebody could give off. I just put one word definition there, vision, or the persistence of vision. If you, let's say, try to give this consecutive display of images, of static images, we could more or less talk about virtual reality when we talk about animation. I mean, these are quite connected ideas nowadays. So the process of bringing life through the use of motion to lifeless things. We can be going towards the level of the art. I mean, to extend these capabilities, or in film production, like, let's say, the frame by frame idea that I'm going to be talking in a while. Now, when we refer to animation, we definitely refer to a number of elements, like, for example, like I said, the form selection, the modeling, the different colors. So basically, we need to attract the audience, and we need to be not only to have the different colors available, but the different shades of a particular color. You have to be able to be giving the correct texture. For example, if we are referring to a rubber ball, or if we are referring to a wooden surface, I mean, this has to be depicted exactly as in real world. Time is quite important with regards to animation, since we are doing movement, since we are doing, let's say, control of this idea. And the last thing that it's of major concern is lighting. So lighting, it's, I mean, if we're referring to, let's say, daily life, spotlights, fluorescent light, or if we are talking about, I mean, with regards to light, you can consider even, let's say, the camera. Where do you position the camera to view, let's say, your animated scene? And if there are hidden surface removal, line removals, and things like that, which you have to take into consideration when you need to, let's say, correctly visualize things, or if something is at the background, which obviously it should be shown. So like the idea that we view out of the window and we identify what is near us or what is far away. As I said, by default, nowadays, when we talk about animation, we normally refer to computer animation. I mean, this is standard, the means is the computer. We can refer to CGI, especially when it is done in movies, and basically the motion, the modeling, the motion, and finally the addition of surfaces and rendering as the final step. So, computer graphics, I mean, if you try to correlate it, let's say, with animation, although, as I said, it used to be a subfield, nowadays it's considered exactly the same thing. So their issues are interrelated. It is difficult to distinguish one from the other. Their improvements have been done throughout the years in parallel. Their effects, their applications, because I'm going to be talking about applications in a minute, I mean, you could really not differentiate between one or the other. However, there is a major difference between the two. For example, understanding and synthesizing motions for interactive virtual humans, you have to do this in a controlled way. So the motion control, the control of the movement. So basically, if I ask you, walk 5 meters, open the door and turn left, for example, I mean, the motion control is the thing that we are looking at when we are dealing with animation. So for this, we have so many different techniques. I'm going to be analyzing a few techniques, and plus nowadays we have a combination of more than one. For example, that comes to my mind that we have kinematics in the early days, we have dynamics, physically correct motion, we have motion capture, which nowadays is a popular, I would say, research way of doing this. A combination of more than one of those, for example, dynamics with motion capture, gives quite attractive results, and I will emphasize in a minute about this. So the 3D animations, they create the objects, and finally they render them. We use standard computer painting tools sometimes in order to, let's say, composite them, and let's say do some kind of tricks in this pipeline of things. And lastly, or parallel to this, we do morphing. Morphing is a special effect in motion pictures and animation that changes or the actual verb of it is morph one image or shape into another through a seamless transition. So traditionally, over the years, such a depiction would be achieved through dissolving techniques, for example, in the film industry. One example of morphing that comes into my mind straight away is the actual thing. For example, you give a photo of yourself, you depict it in the computer, and then you try to visualize, or you morph this photo, and you try to visualize how you would look, let's say, in 20 years or as you age. So basically, there is a transformation from the original photo to what would happen, let's say, in the future. Now, going to the applications of computer animation, I have really categorized them into different areas that I consider quite important. So, for example, in the first category, I put the entertainment, like the gaming, the motion pictures, the music videos, television shows, films, etc. Then I have more practical applications like computer-aided design, automobile designing, and things like that. Advertising, perhaps. So I'm sure that everybody agrees that whenever we see an advert which has animation, since we are visual human beings, I mean, we really remember it and we are more, let's say, interested on that advert, compared that if we see something that it is more static, it is not like the nice colors, the nice pattern, the nice things that we expect to have available. And there's a last category, I put education and training, basically, which is used in schools, in colleges, in training centers. For example, flight simulations for aircraft normally are animated based, or for military purposes, for different things. I mean, this list of applications could go on and on. I mean, I think nowadays anything you could think of could be related, could have some animation in there. For example, I put medicine, which actually a lot of this work, a lot of this research has started just because of medicine. For example, the anatomy of the human body, whereby surgeons can explore the replicas of the human body before they even start doing the operation, the surgery. Advertising, I talked before, in films, we have different film companies, for example, Pixar, DreamWorks, DC Animation Studios, which are primarily involved in doing animated movies, and actually these are where the big money comes from, I would say. The flight simulation for the military, the pilots that I mentioned. Entertainment is quite, let's say, a big area where I mean, a lot of emphasis is given. And here, if you see the pictures that I put, I also put this crowd simulation, whereby, for example, how you would train people if they are in, let's say, in a museum, on a stadium, somewhere whereby they have a lot of people around. How would, let's say, under a bomb scare, a fire alarm, whatever, they could evacuate the building quickly and safely enough. I mean, this is quite another area with a lot of research going on. So how, for example, you would allow a number of people in a crowd to exit the room safely without having any accidents or whatever. For example, collision detection, collision avoidance, or obstacle avoidance. It's part of the things that you have to take care when you consider this idea. So going back to the applications, I think the list is endless. You can be talking about architecture, for example, how you can even view or how you can go in a house, your dream house, for example, and actually visualize it before it has even started building it. But how this idea all started, I mean, as I said, I will go a bit of historically how things have started and how they have moved nowadays. The idea is that we are aiming for 24 distinct drawings for 1 second of animation. So normally the way our eye depicts, and let's say the eye and brain works together, anything above 15 frames and more, our eye cannot really visualize, cannot really understand that this is a frame by frame shooting idea, but we rather identify that that's a continuous motion, a realistic motion. Let me just say that in film industry, for example, whereby a lot of detail is necessary, they use around 60 frames per second. So imagine, let's say, a 2-hour film, how tedious or how, let's say, complicated it would be to create the film, whereby you have to, let's say, be talking about 60 frames per second. The same can be applied, let's say, to correct human movement. So, for example, you can create a sequence of movement through flipping through the different frames, or I put the idea there of the bouncing ball, like you have the, let's say, the interpolation using a keyframe in between, which really gives the illusion that the ball is bouncing, whereas you can be talking about 3 different stages of the ball and then interpolate between them. You could create the nice movement. And let me just say historically how this has started. I mean, how there was this idea of Edward Mycroft back in the 19th century, actually 1878, whereby he was asked by a governor at the state at the time to show that when the horse is galloping, there are instances, actually a very tiny small of time, whereby all the feet of the horse are off the ground simultaneously. So he actually showed that, I mean, the means that he had available at that time, it was only camera. So using 12 cameras along the racetrack, she showed that when the horse is galloping, he's actually having all the feet off the ground simultaneously. I mean, this was a major, I would say, breakthrough in the sense, because this gave the idea to continue this frame by frame fashion to produce. I mean, even nowadays we have some kinematics, some, let's say, even films whereby you give this illusion of movement using a series of photos as they shoot rapidly enough, or perhaps by just flipping through them, let's say, out of a book or whatever. I mentioned before that such a process is very time consuming. You have to, first of all, create the characters, you have to program the movements, you have to render them, and it's also very computational expensive, apart from the labor intensive. So that was the reason that researchers have to find different ways of doing this business. So here I put a number of different styles and techniques of animation, starting, let's say, from more traditional animation and moving to more, let's say, recent ideas. I will stop and emphasize the bit about motion capture because this is something that I work with, and I believe that this is, let's say, the major breakthrough that happened in the area. So mock-up of how it is normally called is using recorded motions which offer precise control. It's of high fidelity. It's the process of digitally recording the movement of the object by placing sensors along an actor, for example, and I'm even going to show some kind of applications on that. These sensors track and record the movement of, let's say, the actor, allowing them to be mapped on a computer screen in real time, initially as a virtual skeleton, but thereafter, I mean, you could give life to this skeleton and you can really be talking about a humanoid figure. The whole thing originated from rotoscoping. That's why I even put some of the traditional techniques there. For example, it comes to my mind the Lord of the Rings, the trilogy, which was a major breakthrough in that work. Let me just say that the mock-up actors put on a fully body suit, normally covered in tracking dots, which corresponds to the key positions in the computer-generated image. The camera then records. Normally you have perimetrically on the room. You could have, let's say, 16 or 12 cameras along the room. So the camera records the position of the dots in the changing distances between them, building a framework based on animation. Nowadays, we have open access databases whereby they record a lot of movement. And what we could actually do, we could, let's say, combine more than one, normally, small slices of this database that exist, and you could create even new movements which are not there. We can be talking about magnetic or reflective markers, optical, inertia, motion sensors, and things like that to do the actual story. So sophisticated mathematics could also be another idea, like, for example, dynamics, which is another good way, I would say, because with motion capture, there are some disadvantages, for example. I mean, if, and I will refer to a project that I was involved, I was coordinating actually, whereby we had to train the police sector. We have to train them to identify whether, for example, they are viewing somebody who is a suspect or who is a thief or which is a killer or whatever. I mean, if we had to record, for example, if he shoots somebody and he fell down, obviously this could not be recorded lively. So what would happen in that sense, we could use dynamics, for example, and with dynamics, depending what you know or what you don't know, what you are trying to find, we have direct and inverse dynamics. For example, do you know the force and you try to find the acceleration, or vice versa? Do you know that you want to move your hand, let's say, at a particular position? So what is the force that I need to apply to my hand to move on that sense? So there are erroneous, I would say, or very serious situations where the motion capture cannot really identify or cannot have available the movement. So there are other techniques. That's why I said normally we do more than one technique. We could have a combination of them, whereby whenever we have such erroneous situation, the other technique, like dynamics, could take over and we could swap in between the two. However, still, I mean, after a number of years of working with this, there is a bit of a problem with regards to the transition. I mean, what would happen at that specific moment whereby we transition from the one method to the other and back again, perhaps. So there's still some research going on with regards to that. Now, behind everything, like it is expected, we have the sophisticated graphic user interfaces. Normally, they are quietly used to define the animation. I mean, here it comes to my mind, and I even put a pic there, just we have that some game engines nowadays, which allow even a non-programmer with ready-made built-in functions and features to do whatever he would like to do easily, for example. But then again, I mean, this is, the possibilities are endless. In this slide, I have put a number of the classical, I would say, films, animated films, normally 2 or 3 minute films, which basically I like, I mean, my personal choices, which no matter how many years they have passed, I mean, I think they are the major breakthrough. I mean, the classical ones, I'm sure that some of you know Toy Story, for example, or Shrek, or Finding Dory. And I mean, it was really something that I enjoyed looking back then. I still do. And I need to say something at this point. I was really impressed when I started, I mean, years back, when I started seeing, for example, all these animated stories. As I said, 2 minutes, it was the max that you would expect at the time. However, when it was done, I mean, when the story was finished, I was amazed to see how many people were really worked in producing that story. I mean, that was really something that I always admired and was always impressed. how many people, and especially how many people from different disciplines had to work, still have, but they had to work at that time in order to create a 2-minute animation film, for example. I mean, I don't know if you agree with this, but yeah, it was something that, for me, it was something like a surprise. I mean, like impression. Here I put some keywords. I talk a bit about most of them, I would say. I talk about direct and inverse kinematics, direct and inverse dynamics. I mean, where we are dealing with such cases, we have to be talking about coordinate systems, about rendering, the morphing, and things like that. I mean, this is more or less for, let's say, thinking rather than, I'm not going to go into the detail of each and every one of these. The future. I mean, if somebody could predict, if somebody would, let's say, suggest, have an idea what would happen next, I just put indicative there that the current level of animation to be replaced with virtual reality. So basically this idea that you could not really distinguish one from the other. And another idea that perhaps you might agree, the person watching a movie to see himself in the movie as the person watching from the side. Or perhaps, and this is something that it has been done at a certain stage, perhaps you could decide on the movie, or you could decide, for example, if you want to have a happy end, sad end, or you could really get involved to what you are viewing, or to how you would like the whole thing to process. So computer animation, I'm saying, to become the standard way, perhaps, of making every kind of movie, not just animated movies. Some of you might agree, some of you might have a different thinking. So what we are looking at, we are looking at a realistic simulation of humans, photorealistic human characters, undergoing physically correct motion. This is quite important. I mean, realism compared to the real time that I mentioned before. And here I put some, I would say, areas that on some topics we have a lot of progress, on others we are still looking for solutions. For example, facial animation, it's quite an important area, it's quite an important goal for research, whereby we need to, for example, express correctly the 6 basic types of emotions that we have, like fear, anger, surprise, or whatever. We are looking for a system that creates the realistic animation, that operates in real time, that is as automated as possible, and perhaps adapts easily, effectively to individual faces. I mean, we all have two eyes, one nose, one mouth, but then still nobody is similar to, or similarities, nobody is exactly the same as the other person. So we are really looking for ideas like that, and especially how to express the feeling. I mean, I will be talking differently today if I was, let's say, happy, or if I was angry, or if I was, I mean, all this should be expressed precisely when we are doing the animation scene. Clothes, I mean, definitely to be talking about realistic, you have to be talking about the correct clothing that you put. So definitely in terms of movement, that is my actual concern. I mean, if I wear something, a heavy material cloth, I would definitely move differently, or the clothes will move with me differently compared to if I wear, let's say, a silky dress, for example. So clothing, it's quite a big of an area just to work with and to, let's say, identify these correctly. And a lot of progress, I need to say, has been done on that. Here is something that not a lot of progress has been done. I mean, maybe you know this, but here, I mean, there is still a lot of way to go with regards to hair. Hair is a bit of tricky in the sense that, for example, we have so many different strands on a normal head, and especially if we have, let's say, kind of wind, or if there is, let's say, a rabbit movement or whatever. I mean, hair, or the way the hair will move is dramatic with regards to, let's say, doing it correctly. I mean, this is because the hair can bend at any point, and even a small distraction, like a small burst of air, affects it. Multiplying this by the different, let's say, thousands of strands that we have, the situation becomes quite difficult. So still there is a lot of work that needs to be done on here. Interaction with others, I think the progress is much more compared to, let's say, the hair. We are still looking though for that. I mean, with regards to the crowd simulation that I referred to, collision detection, collision avoidance. However, the emphasis is always the idea that we have to have no difference from the real actor, no difference from the real world. I mean, we cannot really negotiate on that. The next thing, I put some of the projects I was involved with. For example, you see here an application of a motion capture. That was a project, it was finished. I was coordinating on how to, let's say, train the police force. We call it symbol via the project. How to train the police force to identify how, for example, they would behave if they have in front of them a suspect, if they have in front of them a thief, a serial killer, or whatever. So what would happen in such a situation with regards to emotions, with regards to, let's say, creating different scenarios which are easy to author, and therefore police officers can do better train in such an immersed 3D environment. Another possible application, it's regarding dance. For example, here we have a salsa dance whereby we have the teacher, let's say, and then the actor, the animator, which he tries to mimic whatever the teacher is doing, and by this way to learn dance, for example. This is again using the motion capture equipment. This is another project I was involved with. We have the teacher in blue, the student in yellow, and obviously the student tries to mimic whatever the teacher is doing. Normally towards the end, there are results. So you could even get marking, for example, of how well or how bad you did or what improvements you need to have in order to learn a particular dance. And we are mostly involved in using folk dancing like Greek or Cypriot dance. And my colleague, actually, he even proceeded in some more, let's say, interesting work. That was Andreas Aristidou, whereby he continued with this area of Cypriot folk dancing on how, for example, we could choreography or how we can deal with, let's say, the costumes for our culture. I mean, to continue on this. So basically, that's it. Thank you very much.
Thank you very much, Professor, for your interesting presentation. I understand that this is a topic that is essential in our days. If anybody from the audience have any questions, can leave it now. I have a question. What is the maximum frame of what an eye can see?
15 and above. We cannot really visualize and say, okay, this is a frame by frame fashion. But then, as I said, for example, in film industry, they are looking at something like 60 frames per second, which I think is extreme. But then again, I mean, these are the big money. This is where we really have to be looking for the correct realism. So yeah, but 15 and above, normally our eye cannot really say that that's a frame by frame idea.
So using frame more than this number is not.
Yeah, it's very good. I mean, yeah, it's very good.
Okay, that's my question.
Yeah, it's interesting. This, I mean, it's basically how our brain, our eye work together in order to visualize things.
I have something also to add. If anybody wants to make a question before my comments.
Okay.
No? Okay. Stefania, thank you for this very interesting presentation. I just wanted to add that our project, it deals with digital twins. So
sorry, it deals with?
Digital twins. Digital twins are virtual replicas of physical objects and so on. I agree with you that graphics, animation have great potential in numerous domain applications. I would just to refer to the digital twin framework that we are currently investigating. We are looking into digital twins as a means to develop, for example, serious games. For example, educational applications that have the element of the graphics, of the animation, of the playfulness, of the aesthetics, and so on. And we try to apply these serious games / digital twins in, for example, healthcare support educational processes. For example, in cases in which we would like to educate children with autism or with other mental disorders, or even traditional medical students with, these current trends with the 3D heart, the rotating and slicing and so on. So in such applications, I think animation is quite important. Did you have any experience with such case studies? I mean, this type of utilization of animation and graphics in developing something that could be used, for example, in healthcare or other training activities, such as I saw the police example, which is a training, it's a serious game for law enforcement, let's say, representatives. Do you have any other similar case studies that mostly relate to the healthcare sector?
No, nothing really. But I think this is something that we could, let's say, collaborate with. Yes,
this is my next comment. I think your background and your experience could be very helpful for our group. Yes, we are going to pursue a collaboration in the future. So yes, that was my.
I mean, we started off with this police force, like you mentioned, but then we move on to more dancing to the cultural heritage business. So, but nothing in terms of medical.
Okay, I have something in mind, but let me get back on this at a later stage.
Oh, okay. We will.
All right, thank you very much, Stefania.
Thank you.
All right, our next presenter for today is Miss Elia Guzari. She is assistant manager in KPMG, and she is going to present to us the art of process mining. Elia, when you are ready.
Hi.
Hello.
Thank you very much for the invitation. I'm very happy to actually be here with you. Thank you to Professor Andreas Andreu and his team for making all the necessary arrangements. This is a very insightful project. Thank you, Professor Stefania, for your presentation. It has been really enlightening, actually very interesting. So, as mentioned earlier, I am Elia Guzari. I am an assistant manager at the Management Consulting Department at KPMG in Cyprus. I am a PhD candidate in software engineering at Aristotle University of Thessaloniki, focusing on process mining. And I have a computer and information systems background from Aristotle University of Thessaloniki and University of Cyprus. So today I will be talking to you about a relatively new research area that is process mining, since it has started early 2000. But I will be focusing mostly on its business aspect and not so in the academia part of the field. So I will be sharing my screen, and please let me know if everything is okay so that we can begin. Just a minute. Is it okay?
Yes, we can see it.
Perfect. So we will be firstly having a brief introduction to process mining, see some fundamental concepts, the foundations behind this area. Then we will be moving into more behind the scenes of the art concepts, examining how can we initiate a process mining project in order to reach to the conclusions and the outcomes that will enrich the way we operate. And finally, I will explain how we have started applying process mining in industries in Cyprus here at KPMG, and we will be seeing a video and some case studies. So, the biggest source of competitive advantage for a company lies in the most granular operational details. And that means the data and the actions that lie beneath the systems, the assets, and the people. Most of the time, there is an invisible flow of these data and actions. But if we get the opportunity to look into them, we can provide unlimited acceleration and maximize our operational efficiency and provide more customer value. So in the business aspect of process mining, this is where we're focusing on how to achieve operational excellence, how to save money, and how to better deliver our products and services. But what is process mining? As I mentioned in the beginning of the presentation, it's a new research area. It was initiated at around 2004 and 2005 by Professor van der Aalst and his team, where they actually explored this concept by focusing on the business process modeling and the data mining and machine learning algorithms, where they try to actually combine both of the fields and create an area where they could actually look at the processes, but also apply artificial intelligence on the models that are extracted from systems to actually get all the benefits this might bring. So process mining consists of process discovery and conformance checking. And of course, by applying some predictive analytics, we can enhance our processes and monitor them to better achieve our business outcomes. Process mining helps us answer questions like, how do you know what really happens in your processes? For example, we have the payroll system of a company. We know that we will process all the data in order to pay the employees, provide any letters, make any payments. But what is behind these actions? How do we transition from one step to the other? Or if we are processing invoices from customers, how long does it take from one system to transfer some input to the other, or prepare the output and simultaneously send it out 2 ways? So we actually get to see with process mining how each process is executed and how each process step adds value or delays the final outcome. How do you learn about harmful bottlenecks, inefficiencies, and compliance issues? Do we know that all processes are indeed followed as they should? In terms of internal audit, we can use process mining in order to ensure that the processes are executed as they are supposed to, because we get the opportunity, as we will see on the next section, to actually get an insight of every action, every instance that takes place in a system. How fast, excuse me, how fast can you get insight into your processes? There have been times where we could get a report at the end of the month, and there we could see, let's say, how many applications had been processed, or what were the total amount invoiced for a company, and so on. Nowadays, with process mining, we don't have to wait for checks that are performed on a monthly basis, quarterly, or yearly. We get to monitor them on a real-time basis every day, the moment that every action, every process takes place. And how do you find out where to improve your processes? So, okay, let's say we have identified some bottlenecks, but how can we fix them? How can we save some money? How can we save time? Process mining, with the use of predictive analytics and the advanced tools that are available today, can highlight at the touch of a button the areas of a process that can be improved and show us the way that these processes would swift in order to match the happy path, the optimal path, as we will explain in a bit. Now, on the right part of the screen, you see a picture of a process map. We will be seeing some more of this later on, but just so to get you on board, let me explain that on the screen here we have a process map. We have in the nodes, we have the process steps that actually take place within a process, and every edge from one node to another corresponds to a process step. Now, in this specific image, the darkest, the color of the node or the edge, it means that we have the more replications, the more frequent revision of these steps inside the process execution. For the edges and for the nodes, we can select, depending on the tool that we are using, we can select filters, and we can focus on the time to actually monitor the performance, or we can focus on the frequency to actually check the conformance, and so on. So process mining is a data mining technique that allows for the analysis of business processes based on event logs that lie on transactional data captured in IT systems. During process mining, specialized algorithms are applied to event logs from data sets in order to identify trends, patterns, and details contained in event logs recorded by an information system. So we understand here that we are focusing on the process, but in order to get this process and the whole picture behind the process to reach better conclusions, we need to have a specific format of an event log that we will be explaining shortly how it is created. And it's of prominent importance to actually get specific fields out of the systems. And in case we are using various systems to complete a process, we will need to consolidate all this data into an event log so as to capture the process from its initiation to its final step. So process mining is helping enterprises optimize each and every operational element for better outcomes, extraordinary experience, and better performance. It's a step-by-step methodology that helps us discover, enhance, and monitor the core business processes at the deepest level. We get to a point where we can actually have control over every action that takes place in a system by every resource for every process. So we can identify instantly if there are delays, if KPIs are met, or if there are conformancing issues, especially in critical processes of the organization. It's a prescriptive analytic solutions to find and resolve, of course, the true root causes of friction invisibly embedded in the systems and operations. So we know that something is wrong, but we actually get to see it on screen, highlighted, and that way we can better address it instantly. And it's a holistic bottom-up approach so as to reach operational excellence and use all the technologies and tools available today to help us meet our KPIs, automate our processes, and better work on our everyday tasks. Now, process mining is used for collection, discovery, enhancement, and monitoring. The collection part, that it's the first phase during a process mining project, is the phase where we actually need to gather the data that we're going to analyze. Of course, depending on the organization, because process mining can be applied in any scale at any organization of any field. So depending on the organization, we will need to identify the systems that produce this data that will be used for process mining. We need to get on the logs of such systems, retrieve the data, and bring them in a suitable form to actually go to step 2, that is the discovery phase. Now, the discovery phase takes the data that are collected by the systems, applies them, the process mining algorithms that are used by the process mining tool, and depending on the tool that it is used, there are specific types, families of algorithms, if you like, that are applied in the data, or there are also academia tools that allow the user to actually select the algorithm to be applied based on the field and the process that they are trying to explore. And during the discovery phase, we actually get to see the output as a process map that corresponds to a picture that we saw earlier. So we actually get to see those nodes and those flows, and we can see the paths and all the statistics behind this process. So once we discover the process and we have it in front of us, we can identify ways of improvements. We can enhance our processes. We can see the various paths. We can highlight the most quicker, or we can highlight the one that benefits us more in time, in money, in number of resources involved, depending on what we are trying to improve or what our final target is. So we get to see the ways that we can make the process more efficient and more robust. And finally, on the monitoring stage, where usually comes as a last step during an engagement, during a process mining project, it's the phase where we try to have an ongoing process mining initiative in an organization, where the stakeholders or the business users that have the authority can monitor specific KPIs for the specific process, so that they can on real time monitor the processes and proceed with adjustments where necessary instantly, without waiting to get to the end of the month or the end of the process or the end of the year. Now, during the collection phase, we have lots of data engineers usually involved because we have to retrieve the data from source systems. We need to transform them to event logs, and we need to facilitate the process mining tool to actually visualize the processes. Most of the times, these logs have a lot of noise. They might contain a lot of textual information. We might have a lot of redundant data. We could actually have lots of columns and sub-steps or sub-actions that are not of importance on a given moment. And so we require for data engineers to collect all these logs and proceed with data cleansing and data preparation activities, so as to bring them in a suitable form to provide them as input in the process mining tool. Nowadays, of course, there are process mining tools that have data cleansing, data transformation capabilities, but of course, based on the level of analysis these tools provide, of course, we have the relevant licensing scheme. So, following the collection, we have the discovery. As mentioned earlier, in the discovery, we have the process analysts and we have the process mining experts. So, following the visualization of the processes, we now require for process analysts to investigate, to read, to translate, if you prefer, these process maps that are extracted in order to discover a process, because we could be applying a process mining algorithm to see if there is a specific process followed in the organization. So we can actually discover the process. We can proceed to conformance checking to see if what has been stated by, let's say, the managing board of a company is actually followed, or if the regulations in control functions have been followed, and if this is reflected in the processes or not. Also, a process analyst is the one that will identify or point out, if you prefer, some points that could be proposed for improvement at a later stage, and can actually explain why some delays are presented in specific steps so as to better address them in the enhancement phase. So in enhancement phase, we need the process analysts and the business users, because the business users are the ones that will actually explain what they are trying to achieve. They will articulate how their process should be executed and what the final result should be. So we form a team, we sit together, and we try to explain the visualization that we have in front of us. And at the same time, we are trying to figure out which is the optimal process path and what can be done with the bottlenecks that have been identified. At this point, we are trying to focus on identifying the tasks that can be automated. And this is something that also can be pointed out by the process mining tool. If it contains such analytical capabilities, we can suggest intelligent actions, and we can proceed to some proactive process interventions. So once we have enhanced our process, we can proceed to monitoring. In monitoring, we have the executives, we have the managers. They are the ones that set the KPIs. They are the ones that will be focusing on monitoring the results that are presented by the process mining tool. They will track the key metrics, they will benchmark continuously, and of course, from time to time, they can also perform a process conformance check themselves. This can be achieved by exploiting some capabilities of the process mining tools, where we have some allowed behaviors recorded in the system. And so every time there is a process step or a process instance that is completed that does not conform to that idea, then it can provide us with an alert where we can investigate each case individually and see who performed the unauthorized action, what was the reason behind it, and decide whether to keep it or investigate it a bit more. Now, why use process mining? It's impossible to optimize a core process for a specific business outcome without a holistic understanding of how the whole landscape is connected. So the process mining field will deliver deep visibility and control into the details of individual processes, the relationships between them, and the outcomes they deliver. We get the opportunity to analyze everything. As process analysts, as process experts, we might have an idea on what is going on specific processes in an organization, and we can brainstorm and we can discuss and we can use whiteboards to actually write down the paths and the steps. But process mining examines everything that happens behind the system. So we get the opportunity to get this holistic view and shed light to areas that wouldn't be obvious in any other way or with any other analysis initiative. Now, process mining is system agnostic and process agnostic, and that makes it an ideal candidate to be applied to every organization on any field at any level. So system agnostic means that we can have any underlying system that captures data. It can be any standard IT application. It can be an ERP system from a major vendor. It can be an instrumented devices. It can be a login system of a company. So it can be used to collect data from any system that records data on its daily transactions. And it is also process agnostic, and this means that it can be applied to education, to heavy industries, to banks, to insurance sectors, to retail, to customer experience, to healthcare. So for every field where there are processes, we can and where there are systems in place, we can actually select, identify the suitable process mining tool for us and actually apply it in order to benefit from its use. So what we have on the lower part of the screen here is the process mining solution that is using the business logic that is provided by any business user, any organization, by collecting data from any system that records data in order to provide us with a specific process map. So what is behind that process map is an event log that is as simple as the one we can see here. Of course, we can have event logs of millions events, of millions columns, depending on the organization. But here we have a rather easy one for the sake of the example, so as to get an idea on what can be resolved by using the process mining. So what we see here is that we have an ID, let's say 1, 2, 3, that is the order, and we have specific activities that are used in this organization, provided by the business logic during the analysis phase. And then we have the timestamps and the resources that are captured by the information systems below that are used in the organization. We retrieve those data, they are passed into the process mining solution so that they can automatically produce the process map that was shown on the previous slide. And so it's system agnostic, it's process agnostic. On the left part of the screen here, we have some internal audit areas that we have been applying some process mining initiatives, market to order, purchase to pay, accounts payable, audit. And on the right part of the screen, we have specific industries where process mining has been applied in banking, in telco, in production, in insurances, and so on. So we got an overview of what process mining is and what the fundamental actions or activities of process mining are. And now we will dive a bit more into how process mining is performed. So in order to be able to execute a process mining activity, we need to have the data captured from the system. So the following attributes are absolutely mandatory in order to be able to form the process map. We need a case ID, so we need to have the identification, the key that will be used to group the activities that are performed. We need to have the activity, a name of that action, so as to visualize it on a process map. And we absolutely need the timestamp, the when, because the timestamp is what will define the sequence of steps, and it's of course what will define any bottlenecks and any delays or optimizations that can be performed in a specific process. We can of course have the resource. Some organizations request that we keep the resource so that they can perform the process conformance check and identify the resources that were not conforming. And of course, we can also have some other columns, some supporting activities that will provide a more detailed process map, but it will make it more complicated, at least on a first reading, on a first level of analysis, to actually identify steps for improvement. So what we actually do when we have supporting activities that are used in conjunction with actual activities is that we keep the activities on the first analysis review, so that we get the overview, the process map, and then if we want to focus on specific support activities or to check their burden, if you wish, or their contribution in the overall execution of a process, we will introduce the second column as well with the supporting activities, so as to allow the tool to make a more in-depth analysis. So, okay, this is also follows the previous slide. We can use event logs that are automatically created by major ERP vendors such as SAP, Oracle, and Microsoft. And you can imagine these event logs at the first level as simple Excel spreadsheets or CSV files that can also be manually edited so as to transform them, prepare them to be inputted into a process mining tool. Now, depending the process mining tool that we are using, we can perform the data cleansing inside the tool. In case we are using a simpler tool, we will have to do this manually, and of course data engineers will be required so as to merge the event logs, the logs exported from various systems in order to form one combined event log. So from this event log on our left part of the screen, the process mining solution will group all the actions by order ID. It will check on the date, the timestamp, in order to find the sequence of activities, and depending on the time and the number of times a specific process step was found from, let's say, activity submit to activity check, it will count the frequency as well to present us with the overall process map. What we see on the right part of the screen now, it's something like a spaghetti model. A spaghetti model is what is extracted. It's the first output of a process mining tool when it's trying to illustrate on the process map every activity, every process instance that appears on the event log. Of course, it's not convenient or useful to analyze a process by using a spaghetti model, and thus we are using filtering that is provided by every process mining tool in order to focus to mainstreaming behavior, so as to identify the optimal path of a process. And then, having in mind that optimal path, we can again go and zoom in and get an idea of every process instance so as to perform the conformance checking and check the other variations to see why they are performed in such ways, if they are costing us money or time, if they are violating any regulations. So in the discovery phase, where we are actually analyzing the process maps, we are focusing in analyzing any points of friction, where there are problems inside the process, where there are delays, where there are loops that they need to be resolved. We are focusing on discovering the optimal pathways, the happy path and the process variants. And I will return to this in a minute. And of course, we are trying to check by what was described by our business users. We are trying to see if the business outcomes are met, and if not, how will this be achieved? So we are trying to focus on finding the happy path. The happy path, it's the most, it's the optimal path that is available for a specific process. So in the overall sequence of steps and the overall execution of a process, there is a specific sequence of activities and transitions that, when followed, it will lead to optimum performance. So that is our happy path. It could be the quickest path, it could be the shortest path. It depends on the field, it depends on the organization, it depends on what we are trying to achieve. So we are trying to find that happy path, and then we are trying to see all the other paths that are called the process variants, because they show us what variations exist in the execution of the same process. So later on, we are trying to transform all these process variants to match or to get closer to that happy path. If we need to eliminate some steps, or if there are some steps that can be automated, and these are highlighted by the tools, this will help specific process variants to match the happy path. If there are process variants that do not conform to some rules of the company, we can highlight them and we can investigate them in order to explain this behavior. So during the discovery phase, we are focusing on the bottlenecks and how to resolve them. We are focusing on if the business outcomes are met, and of course, identifying that happy path and examining the process variants so as to make them match or come as close as they can get to that happy path. Process discovery creates a complete picture for every process by exploring an interactive visualization of key metrics. These key metrics that we can see here are available in every process mining solution. We can see at any given time the number of cases or items that are investigated that are part of this specific analysis. We can see the total value of cases and items, either financially or in the volume. For example, we have, let's say we are analyzing 1 million events that correspond to, let's say, 300,000 cases. So we can get an idea on the depth of the analysis that we are performing. We can see the number of steps in the process. For example, in the optimal path, it could be 5, 6, 7, and in some variants, it could be either less if we are skipping some steps, or they could be even more if we have some replications or some loops that we're trying to eliminate. So this allows us to actually contradict the process instances one with the other. We have the number of different variants, so we can see the number of the different executions of the same process within an organization, the number of cases and items that flow through each variant. For example, if 80% of the events follow the happy path, we can see an actual number of the cases corresponding to that percentage. And if we have a variation that violates, let's say, some conformance rule, we can actually go and see if there are 5 cases, and we can actually see the actual sequence of steps for those 5 cases individually. And of course, we have the visualization of steps and variants as illustrated in the process maps. Now, process analytics uses powerful AI to understand the root cause and enhancement opportunity of every process variation, determine its operational significance, and prioritize your response according to its impact on meaningful KPIs tied to key business outcomes. Depending on the tool that an organization will choose to use for process mining, there are a lot of opportunities to actually exploit these AI capabilities that are now presented. There are simple tools that will analyze the event logs and provide the visualization maps along with the statistics as these are presented on the process discovery column. But there are also advanced tools that they can actually showcase how a process can be instantly fixed, improved. They can actually highlight with red or yellow points that require attention instantly. They can calculate the amount of money or time that will be saved if some steps are automated or if some steps are excluded out of the process, in order to help us work on-time delivery, working capital, customer satisfaction, automation rates, and so on. So there are specific tools available for every size of industries, and depending on the business outcome that the organization would like to achieve, specific fundamental algorithms can be used. But then if they are used along artificial intelligence, they can provide a lot more insights, and the benefits will be even more bigger in the organization. So after discovering the variations and root causes in an event log, the focus shifts into identifying any enhancement opportunities. So we have here We can correct the errors. We can remove erroneous steps or add new steps in order to, let's say, perform segregation of duties or define that segregation of duties will be followed. We can reduce any manual effort. If we see, for example, a process step that involves, let's say, processing an invoice and then sending by email the invoice to a specific employee to forward it. If we identify that this can be automatically done through the system, we can eliminate this manual effort and we can skip the step in order to improve our performance. And of course, improve orchestration, standardization, and governance, and of course, proceed to increasing rates of automations. Process mining is an ongoing process within an organization, and continuous monitoring will ensure that the processes executed will always be in line with the business needs. So what do the key stakeholders, what do the managers actually want to achieve, and why should they use process mining? We need to monitor our processes on a daily basis, constantly, so as to ensure that we are meeting our KPIs and business outcomes. So if we know that we are applying process mining in an organization, especially in organizations where internal control is of critical importance, or in heavy industries where the production is very important to be executed efficiently, or in any organization in general, if we know that process mining is executed, we can hold the teams accountable to progress against targets. We can provide our employees or our managers with a clear picture on what is going on a daily basis, and if we are falling behind on schedule on what was supposed to be on a higher level today. We can course correct in real time. We can identify a bottleneck tomorrow. We can call the process analysts. We can call any stakeholders of the process. We can discuss and we can find ways to improve the process without having to waste a lot of money or time. We can grow engagement across different teams. We can build demand for further process mining initiatives across the business. So what usually happens is that our clients call us to apply a process mining proof of concept into one area that they consider important in their organization. So during that analysis and during the monitoring phase, they get to identify the advantages this brings in their own organization and not just on paper. So once they get to see how the process is streamlined, once they get to see that they get some alerts or they can meet their KPIs, they understand or they examine the possibility of applying the process mining function into other areas as well that are less important, let's say. But eventually, by automating all these processes and ensuring that all processes are executed in their optimal way, they reach operational excellence, and such they deliver the best business outcome possible, and of course a better customer experience and employee experience in some cases. That was of course mentioned in the beginning of this presentation. And of course we can communicate success upward and outward. We can indicate, we have measurable items to show us that, you know what, this is working perfectly. We have eliminated any frictions. We are now saving money. Our revenue has increased, and so on, so as to enhance the spirit within an organization. So what do we do in KPMG? First of all, at the moment, we are the only company in Cyprus that can offer process mining engagements to our clientele here in Cyprus. And we have also collaborating with clients from other countries in Europe and Middle East, because it's a relatively young area that has started to grow in Central Europe, but it is just now starting to penetrate the Cypriot market. So what we're trying to do is actually reach out to our clients and let them know that they have here an amazing tool that can provide them with amazing capabilities on what they can do with their everyday businesses. There is a variety of process mining tools in the market today. Some of them are licensed in a couple of thousands per month, and others, of course, are more expensive, depending on the industry and the initiatives, the process mining initiatives that an organization will select. There are a lot of tools that can be used, and they can all get the benefits of process mining without investing a lot of money, at least at the initial stages. KPMG has formed alliances with the most popular process mining vendors, and here we have just a few of them. We have PROM, that was the first academia tool that was developed for process mining, and it has been the foundation of the rest of the tools in the years that followed. We have Disco, that's very lightweight, especially for small and medium enterprises. And then we have, of course, Celonis, that has been leading the market of process mining worldwide. We have Minit, we have Lana, we have Mini, MyInvenio, and Signavio that have been acquired in the last months by IBM and SAP International. So we are seeing that global companies that invest on software acquire these startup firms in order to provide process mining capabilities in their ERP systems that are used in every organization globally. And in the past months, we have seen UiPath providing some process mining capabilities in their software suite. And of course, we have Microsoft that tries, along with the Power BI and other process mining capabilities, to enhance the process mining feature into their software solutions. So what we can offer at an initial stage for everyone to experience the benefits of process mining is to create proof of values with our customers so that we can get them involved, we can have an analysis and identify some areas where we could actually investigate their processes so that they can see the benefits. We will need the business analysts, the process analysts that will be able to read the process maps, the output of the software system. We will need the IT teams to provide access to the logs of the system to clean the data. And of course, we will need the analysts to actually use the sophisticated algorithms and AI capabilities so as to showcase the enhancement capabilities and of course set an environment where the customer can monitor on a real-time basis the results of process mining. Usually, following the process mining analysis, we can create a custom dashboard depending on the needs of the customers, where they can see those KPIs on a real-time basis. They can see the instances that are executed. They can identify any delays. And of course, they can extract reports for specific periods so as to better disseminate the results in the organization. So how we would go about setting up a process mining project, we would have to firstly extract the data from the various systems that are used in an organization. We can get all the data that are part of a specific process from every system that is used to complete the process so as to get transparency and get the entire value. In case we only focus in one system, we will miss specific steps, specific actions, and although we will get a glimpse of how a process is executed, we will not have a clear picture, an end-to-end representation, visual representation of what has been going on regarding that process. Extracted data can be transformed into the necessary format, either by using the tools or with the help of data engineers, data scientists that will prepare the event log so as to perform the process mining. And then, of course, we can get the dashboards, the presentation, as they will be processed by the process mining solution, and set up an environment for monitoring, proceed to any enhancement capabilities so as to identify the significant business outcomes this will bring to any organization. So possible benefits, of course, process standardization. Instead of having the same process executed different ways, causing delays, we can detect the process variants, we can identify the deviations, we can find the happy path and try to create a standardized process that will be followed throughout the execution of the process. Process performance, we can see all the process instances, we can see which are causing delays, and we can get detailed insights. We can have the automation rate pointed out by the software solution that we are using. They can identify by looking at the data some steps where we can apply, for example, robotic process automation so as to eliminate manual work and show room for potential automation in the near future. We can control the process cycle time, and of course we can reach the optimum cycle time for a specific process. We can find the improvement points within a process where we are losing some time or where we have more resources than the ones required but are involved. And of course, we can have an integrated view of processes end-to-end. We can bring the teams together and work in a more collaborative environment, and we can provide value for the business, but of course, enhance their internal audit opportunities. Now, I'm not sure if we have some time. I have a short video here. Do we have a couple of minutes?
A couple of minutes, yes, we can do it.
Okay, I will be, if the video plays, I will be demonstrating a case that we have done in KPMG International along with Microsoft Power BI, so as to provide some process mining opportunities to a client. This is with the use of Microsoft solutions and some developments internally from KPMG, but of course we can offer this with any software tool acquired by the customer. So let me know if you can see the video. Can you see the screen?
No.
Okay,
we can
just
see
a
the
minute.
PowerPoint.
Okay, I will share the screen and not the window. Just a minute. Apologies. Okay. So I hope the sound is okay.
KPMG Process Mining visualizes actual business processes with Microsoft Power BI. The processes are created from transactional data and do not need any user modeling. This ensures process analysis without bias and provides full end-to-end process transparency. It aims to help businesses find and present better alternatives to real-life processes to make them more efficient and controls more effective. The following example shows a procurement process from the creation of a purchase request to a payment release that has been analyzed in 3 specific use cases. The analysis starts with a general overview. KPMG's process mining tool visualizes a process flow with all of its different variants, identifying previously unknown processes. On average, this identifies several million euros of operational waste. The process variance chart gives a detailed description of each identified variant. Select any group, and the other key performance indicators and process flow automatically adapt, allowing for even deeper analysis. KPMG's process mining method not only detects inefficiencies, but also helps to identify their causes. This dashboard shows the total number of late payments and the total volume lost due to them. 4 million euros can be saved easily by identifying and removing the causes of late discounts. To reduce the number of delays, the dashboard shows that invoices must be edited 3 times faster on average. Process mining helps us identify organizational units that take too long to complete their tasks and need to improve their performance. Once identified, you can make the processes more efficient and late discounts less likely. The time schedule dashboard provides information to help cut throughput times. For example, there are a number of process variants here that take almost 200 days, 10 times longer than the average net period. Move your cursor over the bars and you'll immediately see which processes should be eliminated. Here you can also see that it takes 6 days to create an invoice after the goods were received. Creating invoices faster delivers recurring cost savings of more than 1 million euros per year. KPMG's process mining turns data into insight and insight into value to help you get a deeper understanding of your client's business.
So I would like to close with a remark from Professor Will van der Elst, the father of process mining, that has stated a few months ago that nowadays not using process mining is a sign of self-neglect, showing an inability or unwillingness to manage processes properly. Hence, not just using process mining should require justification and not the other way around. We have some amazing tools available today, and we should exploit them in order to move towards operational excellence. Thank you very much for your time. You can contact us for any inquiries, and I will be happy to take any questions.
Thank you very much for your very interesting and clear presentation. If the audience have any questions. Okay, if not, we can continue to the next presenter.
Thank you very much.
Thank you.
I have one question, Elia. Thank you for the very, very informative presentation, as usual. I was wondering, and this is not a question actually, but a comment. I would like to hear your opinion about the maturity of AI or machine learning tools or techniques or algorithms that may help process mining reach a different level. How do you think this? What in your opinion is the maturity? How can we rely? How much can we rely on such tools today for discovering any hidden information within the company's logs?
Thank you, Professor. A great question, actually. Well, if you had made this question, let's say 3 years ago or 4 years ago, I would say that we have a long road ahead of us. But I have seen in the last 3 years tremendous progress in the tools that are available for process mining. We started out with only an academic tool and DISCO that was based on the academic tool. And then we started having tools like Celonis that nowadays are powerful organizations. I think Celonis was actually awarded as the most successful data company for the year that passed. They have put a lot of effort in these analytical capabilities on transforming the data and incorporating the AI. So there are at least 2 tools today that we could rely on them, I think, with our eyes closed. However, their licensing schemes might not be the best the best they have to offer, especially for small and medium-sized enterprises, and especially for organizations in Cyprus. For the rest of the tools, that they do have a lot of capabilities, they do provide the analysis, but they do not provide such insights on how the processes can be improved or automated. We still have a while to go. But we are in a very good road, and we of course have solutions that we can depend on without worry.
Okay, thank you, Elia. And this is where universities and research organizations may step in and possibly provide some solutions, or as the new hype, explainable AI, to be able to justify the way a certain algorithm has reached the solution.
Of course. Thank you very much.
Thanks.
Okay, our next presenter is Professor Lambros Lambrinos from the Department of Communication and Internet Studies from the Cyprus University of Technology. And he's going to present to us the topic of integrating the Internet of Things in real-life scenarios. Mr. Professor Lambrinos, if you are ready, we can start with your presentation.
Hello, can you hear me?
Yes.
And the screen is okay?
Yes, it's fine.
Perfect. Hello, everyone. I'm Lambros Lambrinos. I'm at the Department of Communication and Internet Studies at the Cyprus University of Technology. Thanks for the invitation to give a presentation in the second school on smart data in the context of the Destini project. I will talk about our experiences from integrating the Internet of Things in a number of real-life scenarios. And we will see that sometimes theory is quite far away from reality. And there are some obvious, let's say, issues that need to be resolved before one considers deployments and applications overall a success. I will briefly talk about IoT in the beginning and then discuss about the projects that we carried out in the past and also show some current and ongoing work. I guess you're all aware of the term. And I try and present a more, let's say, generic view because sometimes you get some differing let's say, definitions. I think IoT is the result of the technical ability of a huge range of devices to connect to the internet either directly or through an intermediary, so through a gateway. There have been various forecasts on its anticipated growth. Some have been successful, some not. Some were over exaggerations, and others were more, let's say, down to earth. Probably the answer is somewhere in the middle. We've seen many applications of IoT in the last, let's say, I would say decade, which are changing the urban and gradually the rural area landscape in many domains, mentioning just a few: transport, energy, environment, health, manufacturing, retail, etc. There has been differing penetration in each different sector, and this is where mainly various efforts have been focusing. Trying to, let's say, picture the IoT landscape, we see, let's say, various components there, and perhaps starting from the underlying infrastructure, for which I will talk about near the end of the talk. We'll talk about the universal and efficient communications network, able to carry reliably and timely the huge amounts of data that in many cases minute devices generate. And therefore we have to, let's say, consider whether all these networks are in place or will be in place either independently or in combination with other telco-based networks in order to fulfill the requirements of the different applications. And talking about applications, they are basically the core to the success of the IoT, because this is where eventually revenue will be generated for the application providers in order for them to recoup the application investments as well as the, let's say, infrastructure deployment. We also have the cloud service platform, where essentially all the processing occurs, although we're starting to see many cases where an increasing processing load is occurring at the edge as well. A core part, let's say, of the landscape are the sensors. There's a huge variety of them. They vary in size and cost and functionality. So we have sensors that provide simple temperature readings to high definition cameras. As I said, it's a matter of what a developer, let's say, or a company is prepared to pay for the sensor, and they get the corresponding quality. So it's all down to the needs of the application. From the point of view of the requirements, I put down a few major ones which have to do with sensing frequency, the accuracy of the sensing. I mean, I talked about the temperature sensors. Then there are some which have a plus or minus 1 degree accuracy, whereas other applications might say, oh, this is not adequate for me, so I need a 0.1 degree accuracy. So they would go for the completely different sensor in terms of quality and cost as well. Then we get data categorization, processing, and the data delivery, which is one of the, say, obstacles in the smooth, I would say, deployment of applications. I guess you all guys have seen this picture in the past. It's quite famous, I would say, because it tries to depict the huge amount of applications of IoT, and at the same time, though, it provides us with an idea of where we can do things, but at the same time indicates the different silos. And this is where things are, let's say, in a way, concentrating at the moment. But this is a so much changing landscape that we will see later that it's time to let's say, break the existing silos. Perhaps the most, I would say, the initial and one of the most popular applications of IoT has been parking. And the reason is that due to the urban population growth, there is an increase in vehicle use, and therefore one negative impact is obviously on the environment, while at the same time the increase in city traffic puts a huge demand on city parking infrastructures. And I guess we've all been in the situation where we circle around an area trying to find a vacant parking space, wasting our time and fuel, at the same time causing further congestion for other drivers who might be just passing through the area, and obviously increasing our and their aggravation. So the traditional parking model was no longer adequately operational in many cities worldwide. I'll try and differentiate between different parking infrastructures in order to showcase that there are different ways of handling different scenarios. We have the off-street parking spaces, which are primarily operated by local authorities and private companies. Usually they offer a big number of spaces. Most of the times there are barriers at entry and exit to protect revenue. And we gradually see that parking operators are trying to deploy different technologies for access control and payment collection, such as RFID, or automatic number plate recognition systems, as well as more simpler stuff that goes with magnetic cards and short-range RFID. These are ways for them to protect, as I said, and control access to their spaces. On the other hand, we have the on-street parking spaces, which are more convenient as they are much nearer to locations of interest. They're obviously primarily operated by local authorities who impose usage limitations, for example, the maximum stay duration, in order for them to facilitate a better sharing of this resource. Because they are, let's say, much more limited than off-street ones, they are, as expected, they are quite a bit more expensive. So why would one apply IoT in resolving some of the parking issues? From the city perspective, they would gather information identifying hotspots and the peak hours where parking is more in demand. At the same time, they would improve monitoring and revenue collection, while also improve the level of service they provide to their citizens and visitors in the area. Our motivation in doing all this was to, take steps towards solving a real-life problem, while at the same time we try to utilize off-the-shelf components in order to demonstrate quickly the positive impact of IoT to the public as well as the local authorities, while at the same time the deployments would enable us to carry out research in more advanced topics. We actually carried out a project that was quite a while ago. It was implemented in Nicosia in Cyprus and in Chania in Greece. And we started with a survey. What we wanted to do was to identify the needs of the local people and obviously the visitors in the area, as well as the needs of the two local municipalities from their, let's say, parking areas. What we did was we analyzed initially the infrastructures that were offered to the citizens. So in Chania we had pay and display machines, whereas in Nicosia we had the traditional coin meters, pay and display machines, as well as a form of payment through a text message. I'll showcase some of the outcomes we had from the 1,400 driver survey. And obviously we see that a significant percentage, around 37%, had to spend more than 10 minutes searching for a vacant spot. This obviously, as I said before, is a waste of time, fuel, and also causes an increase to the local traffic. What was the outcome when they had these consequences? 34% were showing negative behavior. By negative, we consider to either park illegally near to their area of interest, or completely leave the area because they were frustrated, which means that they wouldn't carry out the activity that they were initially intending to, which implies lost revenue for the council and local businesses, more importantly. Fortunately, let's say the majority try to increase their working time, let's say, and go to the nearest parking which had availability and carry out the intended activity. The 34% though that we identified is a significant percentage that implies that something had to be done. And obviously, through the increasing penetration of smartphones, the vast majority of drivers would be interested in knowing where there is parking availability in real time. And we're quite surprised also to find that a significant percentage would be interested in reserving a parking space in advance and even pay a fee this reservation. This gave us quite a lot of incentive, let's say, to continue our work, because reservation was one of our, let's say, initial ideas. One other thing we asked drivers was whether they would prefer to pay lower fees during off-peak hours. Obviously, the answer to this would be yes, but this pricing differentiation would, let's say, bring a more manageable demand in terms of from the point of view of the city, and therefore it's something that was quite well, let's say, received from drivers as well. In addition to the application, we asked about the ability to receive an SMS, which is, let's say, quite not as easy as through the smartphone. And we were also happy to see that about 50% of the participants wouldn't mind having an identifier on their card to calculate the exact stay duration. One of the reasons we found out that people would park illegally was that they had something to do for a few minutes. So they would park on a pavement or somewhere else in order to carry out the task that they needed to do, and at the same time avoid payment. Whereas if the payment was accurate, they would pay for the time that they actually occupied the space, then they would be a lot more willing to make this smaller payment rather than pay for a whole hour and only use the space for 10 minutes, which is common in many cities worldwide. VMS signs guiding drivers to available spaces, in addition to the applications, were obviously something useful, as well as a variety of payment types. So people are shifting away from the traditional coin payments and trying to do more, use more electronic methods. So our conclusions from that was that drivers face problems with regards to the availability of spaces. They're willing to exploit technology, but at the time of our project was running, the cities didn't have any facilities to provide these features to them. So monitoring parking availability, it's a generic term. I'll try and break it down a bit, because it occurs at different levels. In its simplest form, talking about off-street parking lots, it has to do with counting the number of vehicles entering and leaving the area. For this, a variety of technologies were and are available. Inductive loops are the most widespread and reliable and cheap method. And using these, they would provide the total number of vacant parking spaces in the parking lot, allowing for a number of errors as well in the counting. Digging down, though, we see that we could gather information on the status of each individual parking spot, providing an indication for the location of vacant spaces within a larger space. So if you imagine a multi-story car park, where it could indicate to the driver that there are spaces on floor 5, saving him the time to circle around the first 4 floors. And so we can see that from the parking level, we drill down to the floor level and then to the spot level. However, there's a difference in the way that the information is disseminated, because parking level monitoring would be disseminated across the city, and then floor level and spot level would be disseminated locally. There is no point in providing floor or spot information to a driver who is 2 kilometers away from the car park. You would provide this information when they are actually there. How all this takes place, concentrating on spot level information, different sensors again in different cases. On the right, we see some sort of ultrasonic sensor that is placed on primarily on the ceiling or behind the car on the pavement. And in the middle picture, we see the magnetic sensors which detect the presence of a vehicle. This would reliably work provided that the vehicles park in the designated spots. Whereas we've seen in the practical deployments we made, we've seen some vehicles parked in the middle of two spots, thereby missing the sensor and stuff like this. These are issues that one finds only after doing real deployments. And in the third picture, we see the cameras monitoring the parking lot, and obviously through image processing, we would identify approximately, with a good accuracy, I would say, the number of parking spots available at the parking lot level. Then this information gets disseminated to parking guidance and information systems, whereas they are scattered in strategic places in different cities, as well as the information becomes available on smartphone applications. As I said, always at the parking lot level, and then if you enter the parking, maybe you get information on your smartphone as well on the precise information to park. There is a problem caused by all this, let's say, dissemination of the information, because sometimes multiple cars might be chasing the same spaces. This is, let's say, expected, normal, I would say, and different techniques have been applied to this to, let's say, alleviate the impact of this effect. Moving on to something interesting that, as I said before, parking reservation. The goal is that drivers will find an empty spot when they arrive to the parking place, thereby eliminating the negative impacts of searching, which is highly valuable for the users and the environment. So one would send a request, receive the confirmation, and upon arrival, the driver or the vehicle must be identified so that they are obviously guided to the location reserved. This would give us happier customers. At the same time, it increases the management on from the city side or the parking operator side. So it's highly essential to have accurate availability information. You can't really book a space for someone, they arrive, and there is no space available. Okay. And therefore, at the same time, one has to reduce cancellations or no-shows, which is, they would disrupt the whole operation. So we propose to use some prioritization criteria for the reservations, limit the amount of time that the reservation is valid. Therefore, if you make a reservation now, it will be available for the next 20 minutes, and after that it will be cancelled so that another user can utilize the space. And at the same time, get a small fee in advance for giving the ability to reserve. The reservation policies need to be applied to maximize utilization of the space. You wouldn't want to send away passers-by, drivers simply coming to your lot, and without a reservation, you would need to allocate some spaces for them. So it's down to the operators to decide what to do with their parking spaces. Verification and enforcement are important in this case. So one would try and deploy different technologies in doing that. And also overstays. So if you, let's say, book a space for 2 hours and you are late and your car is still there and the other person comes, what happens? To avoid this, some parking spots must be left empty so that the operator can satisfy the different reservations. Obviously, empty spots imply a loss in revenue. So such a system would have to be running quite efficiently in order to be, let's say, fully productive. There have been smart parking, obviously, deployments in many areas, and pre-trip and on-trip information received helps users in planning. We implemented our own platform, as I said, integrating commercial off-the-shelf components, and we applied the technology at large parking lots, providing real-time information for the whole parking, the individual levels, while at the same time monitoring individual parking spots. This implies more cost to monitor specific parking spots, because obviously there is much more equipment involved and much more maintenance, but it allows the operator to draw useful statistics and at the same time issue potential alerts. For example, there is a car there in spot number 56 parked there for 5 days. Is there something wrong with the car? Is it a car that was stolen and somebody just left it there? So maybe this information can be useful in different scenarios. In the system, we implemented revenue collection through long-range RFID antennas, and therefore there was an RFID tag in the car. If the car was available, was identified at the entry and the exit. So billing was carried out actually by the minute. So people knew that they would pay for the time that they actually utilized the parking space. There are some associated publications there which I could make available to anyone who is interested. And then, building on our experience, we implemented the DisAssist platform, which was primarily targeted in helping people with disabilities in locating spaces available for their use. I don't know what's happening in other countries, but here in Cyprus, as well as Greece, there is a big problem with people occupying these spaces when they're not entitled. It's an increasing problem because parking availability is limited, and the spaces for people with disabilities are strategically located near major areas of interest, so they offer convenient access. But as I said, they're reserved for people with disabilities. So discussing with a few of them, we came up with an idea of doing something to help them in the whole process. I'll play a video that describes the application. Can you hear the video?
No, we cannot hear.
Only image, Lambros.
Only image, okay.
Yeah, not sound.
Okay, give me.
Maybe you can play it outside the presentation software.
Give me 1 second.
Assist. Doing my usual routine.
Now it works, right?
Yes, yes.
Okay, I will go back.
Hi, this is Ken speaking. I'll describe some features of a cutting-edge application called DisAssist. Doing my usual routine, I get into my car and drive towards the city to do my daily tasks. The most difficult part is to be somewhere on time. It's not that I'm always late. I just can't easily find a place to park. I need a special place, a decent one, to make me feel that I belong to this society. There are few but very useful spots allocated for people like me. It's important to know the spots and head directly to them, to keep them in mind, or even better, to have them pictured on a map. The ideal would be to have an application that provides this information and to use it while being on the road or even before leaving home. DisAssist does this, and as well, see in a while, a lot more. The problem begins when disabled spaces are occupied. Through DisAssist, I can be informed about the places that are currently available as they are monitored by special equipment. So, all I have to do is simply drive to an empty spot and park. The LED shows me that this space is available. Excellent. Now that I'm here, I will authenticate myself too. Luckily, I have my smartphone with me. But even if I had my older phone, I could have just sent a text message to the service with a slot number. Simple stuff. The red color has now changed as I verified myself. Guess what happened to me a couple of times though? Until I got there, the spots were occupied by someone distinguished. If the car shouldn't be there, the lamp blinks as it should. To avoid losing my desired spot, I'm exploiting a feature that is more secure from the beginning. After checking the availability, I choose the parking place that suits me and book it in advance. Easy. It is now booked for me, the database is updated, and I get precise directions on my phone to drive there. The moment I book, the LED lamp on the spot goes red. It shows other drivers that the space is reserved. I have to get there on time, before my reservation is cancelled. Once there, I just verify myself at the spot I have parked. I'm using my phone for this, but my friend Mary has a special device that performs authentication automatically. All she has to do is switch it on when she parks. Let's hope that DisAssist is rolled out on a large scale. It will certainly help me and many fellow disabled people park with ease.
We built up on this work and had a continuation project and in a number of associated publications. But it gave us an idea of how difficult it is to carry out, let's say, real life deployments which are functional as well as accepted by the user. Talking about users, in everything we do, we try and involve them from day zero, I would say, because in many cases they know what they need and we don't. So in a way, it's important that the users define the application requirements, increasing therefore the chances of any sort of deployments actually. I talked initially about the base infrastructure for supporting IoT, and so the network should be and is in the process of being created to support the different applications that are gradually coming in the market. Talked about the sensor nodes, which have a connectivity from a few meters to about 100 meters. Usually in that distance, they would primarily hit a gateway whose task is to collect data from sensors and forward it towards the let's say cloud or processing infrastructure. recent technologies are giving much greater distances in communication with between sensors and gateways. This is just an image showing the evolution, let's say, of communications and how we're moving into the 5G and beyond 5G era, and how the different networking technologies are, let's say, utilized in different scenarios. We observe different, let's say, communication modes, either between sensors or directly from sensors to gateway, and then from gateway to infrastructure through different backhaul, let's say, connectivity, which could range from cellular, 4G, 5G, to even satellite, supporting the needs in remote areas or when cellular infrastructures fail, which are obviously the case in disasters. Networking in urban and surrounding areas, primarily for on-street spaces, which are not always covered by the networking infrastructure, providing an increase in deployment and maintenance costs, and with the need to have a longer range in terms of communications, something which demands different, let's say, comms technologies. And one fairly recent one is low power wide area networks. LoRaWAN is the most known, let's say, deployment. There have been others, but LoRaWAN seems to be prevailing. Its job is to carry small amounts of data in, let's say, regular intervals, but only a few packets per day. This is useful for many applications of the IoT, not for others. So, as I said in the beginning, one has to pick the communications medium that's more suitable for the application in mind. And obviously, here we see that power and cost characteristics make low power wide area technologies the only, let's say, ideal candidate for supporting the needs of IoT applications. We evaluated in the past a number of LPWA technologies when they were initially brought to the market sometime in 2015, I would say. What we did was we developed our own node that had a hybrid, let's say, networking connectivity, utilizing 5 different technologies through one box to allow us to evaluate them in different circumstances, while at the same time measuring power consumption from each one in order for us to try and see how autonomous systems would be operating. We did these tests in London, around Regent's Park and around Hyde Park. What we did was we installed antennas on a couple of rooftops, and also had some ground stations. So we tried to measure the distance, the actual distance vs the theoretical distances promised by the manufacturers. And obviously, as one would expect, the actual distances were much lower than the theoretical ones. Obviously, it's known that building trees and other sorts of infrastructure interfere with signals. So one would have to deploy a significant number of gateways in city areas to provide full coverage for sensor data transmission. So companies involved in this sort of operation are, in a way, making analysis, making studies, making plans in advance in order to identify the most strategic locations for deploying the gateways, which, as I said before, would receive the data from the sensors and transmit it towards the cloud infrastructure. We also evaluated underground communication. This would be highly useful in scenarios where one is monitoring the water supply system for leaks, and underground we could, if I remember correctly, we could communicate at around 80 meters distance. Obviously, overground we got communication to the region of a few kilometers in the city center. Building on all the previous experience, there is some ongoing work. Agriculture is an area where we're interested a lot. Obviously, it has a lot of potential application there, and a lot of potential revenue for organizations seeking to develop, let's say, commercial application. The key there, in our opinion, is that we could utilize multiple sources of information in order to draw useful conclusions and give advice to the farmer. Obviously, the most prominent problem, I would say, is water conservation, and so combining weather forecasting with the status of the soil and stuff like this would help the farmers to identify the most ideal times for
Professor Lambrinos.
Most probably some problem with the line.
Yes.
Lambros, can you hear us? No? Let me... Let's give him a couple of minutes to see if he can resume. In any case, we have to wrap up and proceed, Stelios, to the next presentation. So a couple of minutes, and if Lambros is not online again, then unfortunately we have to close his part of the presentation and move forward to, I think it's Massimo and Francesco. Yes.
Yes.
Here, but do we have a break or it's after my first part?
Okay, it depends on you, Massimo. Normally, we should have a break. We should have had a break at just before Lambrinos' presentation. So it was supposed to be at 11 o'clock. So if you would like us to have a short break of 10 minutes, and then you can start, for example, 12:05, it will be better for the audience. So
apologies
and if it's better for the audience, it's better for me as well. So okay, it's okay.
Apologies for the network problem.
Lambros, yes. Lambros, we have to wrap up a bit quickly because we are behind schedule. So if you have a couple of minutes to conclude.
Okay, thank you. Let me try and share my screen again. I was very near the end of the talk anyway. It was quite important for us to, as I said, to try and reach the overall public, and approaching the young generation is quite key here, because they would be the eventual users of IoT. So the application we did, where we provided to them environmental data from 3 different cities, was very well received by them, and the best outcome was that it also increased their awareness of the environment where they live in. And obviously the most obvious question was, why is Limassol much more polluted than Vienna, for example? which was the other city. It was Limassol, Vienna, and Zagreb. And therefore, they started, querying why pollution in the center of Limassol is much higher than in Vienna and Zagreb. That's it, I guess. I don't want to take any more time. Just conclude with saying that I mentioned this phrase before, breaking the silos. In order to have, in my opinion, to have successful deployments on a large scale is to try and share infrastructure and share resources among applications rather than deploying a network for application X, another network for application Z, etc. And therefore, I'm hoping that the various networking solutions will converge towards a single infrastructure that would support the needs of the different applications. Thanks for your attention and apologies for the technical issues. Any questions, feel free to ask.
Thank you, Lambros. Any questions? Any quick questions from the audience? Okay, I had a couple of questions, Lambros, but I will confine myself to just one. Did your system, the parking one, was it embraced by any municipality here in Cyprus or not?
The project finished in 2013. We had a full deployment in one parking lot, and in Nicosia, and the municipality is still operating what we provided to them and maintaining. So this was quite encouraging. But since then, we only now see, which is like almost 10 years after, we only now see organized efforts from municipalities to deploy IoT-based parking infrastructure. So it does seem to take a while for all this to sink in, let's say, or it's a matter of let's say bureaucracy or other stuff.
Yes, and priorities and policy making. The reason I'm asking is because I have two case studies that maybe that can be benefited from your work. The first one is in Paphos. Recently, they started a new division, let's say, on smart cities, and they employed a former student of mine, Zenonas. Maybe you know him. He was in Neapolis. So they are doing a lot of stuff towards smart Paphos. So maybe you should talk to them as well. And I know also that Limassol is taking some steps, and I have a contact there. It's Haris Trikis. It's a member of the board, of the council board. So maybe these efforts, because I see a lot potential to this effort, and I would like to see this being applied in practice and offer the benefits, especially to the disabled people, to be socialized and be part of the society as normal people do, as people with no disabilities do. So this was my comment. I don't know if anyone wishes to make another brief, short comment, because we are really behind schedule and we are planning to have the break. Anyone else? No. So Massimo, thank you again, Lambros. Massimo, let's take a break of 10 minutes. So we will resume at 12 minutes past 12. Is it okay with you?
Absolutely fine.
Okay, thank you.
Okay, I think we are ready to start. Our last presentation for today is from Professor Massimo Mesella and Francesco Leotta from the Department of Computer Controlled Management Engineering from Sapienza Università di Rome. Professors, when you are ready, you can start.
Yeah. Do you see my slides?
Yes.
Okay. So thank you for organizing the school and inviting Francesco and I to give this talk. We will present you a very quick introduction to business process management and to process mining. You heard about process mining early this morning, by very interesting industrial talk. Probably we try to give you a research-oriented view of it, and also to put it in context with respect to the larger area that is a business process management. Francesco and I, we come from the Sapienza University of Rome, and we are partners with Professor Andreas in this project that is organizing the school. Personally, I am a full professor in the department with an expertise on, I start from the area of service-oriented architecture and then moved along the way of the intersection between business process management and IoT and the service-oriented architecture. This year, or better, last year, sorry, 2021, we hosted the top conference in business process management. I say this to give you the feeling that we are really part of the research community that is working in the last year on those topics. Okay. So, why the people should know about business process management? Imagine having a process. What is a process? Maybe what you do when you want to take a trip. The example is taken from the original slide on Marcello La Rosa, that is a friend of mine and one of the authors of the most famous book on business process management. When you want to go to the airport, what you do is that you decide to call a taxi from home to the airport. The taxi arrives after 10 minutes. Then you have to drive for 20 kilometers. Then at the airport, you have to do the online check-in. We have to insert a new step in this example, that is, you have to present your green pass now in order to enter, and then go on and go on. So why I presented this stupid example? Because this is a process. This is an example of a process. In particular, is what you could say an intersection between a personal process of the people that would like to travel, together with the organizational process that are carried out by the airport, the security organization, and so on, in order to make you travel. And how the people model a process? Maybe if you have one guy, you will describe in a very pictorial way. Maybe this is the type of schema that an industrial engineer could imagine to represent the process. Or maybe you have another guy that will do a design like this, because the people needs to model in general. We are engineers, we are computer scientists, and typically you need to represent in an abstract way what you are telling, because a diagram is much more expressive than a set of words in a natural language. Or maybe you can represent in this way. This is an example of a flow chart. Or maybe my kids will represent in this way. You will do a kind of picture that represents the idea of the father, me in my case, that is going to the airport in order to take the plane. And there are many other times. If you are interested in the timing, you will do a PERT-like diagram or a Gantt type of diagram in which you represent with the in which you represent in this way the time duration of the different activities, or again, you can have many other ways of representing. What are the issues? The issue is that, in general, when we deal with processes that are real happening in the world, that should be automated and enacted if we want to make the world more digital and more efficient, we need to represent concept. We may have different level of granularity, we may have different level of scope, we can have different terminology. So the question is, what is the right process model? Why we should represent? Of course, a model can be different stuff. Of course, we would like to have maybe the representation on the left, but we can have many other representation. And a model typically are done in order to abstract real world phenomenon, in order to reduce the complexity. Because when you do the design something, you cannot design everything at the same time. So in general, when you build a model, you need to aggregate information and you need to document only those relevant aspects that are in the context of the design that you are doing. So you need to focus on what is the modeling subject, what is the target audience, and what is the modeling purpose that you have in mind. So in general, when you want to model, and this is very important in BPM, you need not to forget about the right or wrong. Maybe it's more correct to say that you have to focus on what is relevant and what is an irrelevant model with respect to the target. What is a relevant model? For example, if you are an architectural engineer, a construction engineer, you can have a 3D representation of the model, or you can have on the right another model that is the precise diagram, that the plant that is needed when you want to go on the construction site in order to understand when you have to put the basement of the building. So in our case, sorry for this metaphorical introduction. In our case, what is our phenomenon interest when we deal with business process management? Our interest is a business process. What is a business process? Is whatever collection of events, activities, and decisions that involve a number of actors and objects, and that collectively, so the interplay of the events, of the activities, of the decision, of the actors and the objects, lead an outcome that is of value for an organization and for a customer. So in general, you are in front of business process each time that you put those stuff together. Those stuff are events, activities, decision, actors, and object, in order to have some value for someone. You can see that the definition is enough broad to take into account a lot of business activities where business is meant in the larger possible value. Very few activities that we carry out are excluded by this definition. In particular, is included in this definition each time that you have an organization that has to provide value to some customer. If you have a customer, if you are an organization that wants to do business, wants to provide services to some organization, you have to deal with business processes, because otherwise you are not able to really provide those value and to really innovate the way in which you provide those value. Example of process in organization are the order to cash, the quote to order, the procure to pay, the application to approval, the default to resolution, the claim to settlement, and many other activities of this type that whatever type of organization has to take into account. Example, if you are a user and you say that my washing machine doesn't work, you want to call the call center, then there should be someone that is in charge of dispatching a technician that understands where to find the part store that maybe you need to substitute. Then you have to open a claim towards an insurance company that will be pay for the repairing if you are inside the guarantee period, and so on. And typically, if this process is quite fragmented, if you have to lost 100 phone call, as is happening to me in this period of COVID recently, in order to have your machinery repaired, you are very unsatisfied. If conversely you became satisfied, this means that you acquire value. This means that the company will have a high rating because it's work more efficiently. This means that the company will sell more washing machine or whatever service it wants to provide. The customer will be happy. Your company will have a profit. And so you do business process management in order to earn more. That is at the end the objective of any businesses. This is why we are dealing with business process management, because in general, the organization needs to improve the way in which they work in order to make someone happy. Well, happy sometimes means also that you pay less for the same service. So you want to optimize the way in which you provide something in order to make the people pay less. So in general, every process leads to one of several outcomes that can be positive or negative. In general, positive outcomes deliver the value, the negative outcomes reduce the value. And example of default to resolution process outcome can be that default is repaired without technician intervention. You can have a self-repairing machine with IoT that is able to auto-diagnose and repair itself. So why you put IoT in the stuff? Because in this way, the people are happy. In the previous talk, you have seen the example of the parking. Why you are happy? Because the process of finding a parking and on the city municipality to provide a space for everyone has been improved a lot with the insertion of IoT in the process. And this is why that was a very nice example. And we have many other examples of this. So what is a business process in the abstract way? A business process, as we said, consists of event, activity, and decision point. I'm using here UML, Unified Modeling Language, to represent the conceptual model of a business process. So you should have in a business process at least one activity, or you can have one or more activity. You can have event, potentially a lot. You can have a lot of decision point, potentially a lot. Not necessary you should have event or decision point, but necessary you should have at least one activity. A business process involves objects that are typically the artifact on which the process operates, or that are used as input, or that are produced as output, or that are used in the middle of the process. Involves some actor. A business process delivers at least one outcome, because if there is no outcome, no one take in charge to implement a process. The outcome, as we said, can be negative or positive. In particular, the positive outcome gives value to their customer, because there is someone that pays somehow. There should be at least one customer, and notably a customer is one of the actors of the business process. So what are the core elements of a process? Are the activities. The activities are those elements that are active. So you can recognize when you read the text that potentially is a process, because they typically have the active verb. They are time-consuming and resource-demanding, and they are state-changing. In general, they change the state of something. Conversely, what are the events? The events are elements that are passive. You recognize in a text, because typically the verbs is at the passive the conjugation. They represent condition or circumstances happening, and they are atomic or instantaneous, so they don't have duration. What are the business objects or the data? Typically are those organizational artifacts that undergo state changes. They can be either physical or electronic information, as the sales order, a digital object, a consulting proposal, whatever. The actors, sometimes also called the resources, are those entities that performs process activities and potentially generate the events. Can be either human or systems. And examples are the financial author, the warehouse clerk, the RP, the CRM, the SAP, the application XYZ that I have already implemented, and whatever. So how do you combine all of these elements when you want to build a model of the process that then you want to analyze, or you want to design, or you want to implement? So first of all, you need to focus on the control flow. So what needs to be done and when. And for doing this type of stuff, we'll see in a few minutes that there are standard languages, standard conceptual languages that allow you to represent all the relevant aspects that you may be interested in. You are representing in the control flow. So you have this type of diagram in which I anticipate the boxes are the activities, and the way of ordering in sequence or in parallel or in alternatives, the activities are represented with the arrows and with these diamonds that are called gateway. Let me give you the intuition that somehow drawing this type of diagram you can see as a way of programming. Let's say that you are programming the organization. It's not the case that BPM sometimes is called programming in the large. If you are a computer scientist, you are very well used to design diagram like this, because somehow you are giving the instruction to a kind of abstract machine that is the organization that knows what to have to do at each step of the execution. Then what you need to represent, in addition to the control flow, is the data flow. And here we see with this a symbol of the documents that says that the invoice details produce an invoice that is used by the check invoice mistakes. And maybe you need to recover the information from some database and so on. This is called the data flow. So in addition to the control flow, you need to represent how the information flow along the execution of the process. And then what you do is that you have to represent the third dimension, that is the resource dimension. So the humans and the system that are part of our process. We will see that in the standard language, that is BPMN, Business Process Modeling Notation, this can be done by representing these rectangles that are called the swim lanes. The idea is that the entire process is a big pool in which the swim lanes represents the different actors that execute the activities. So what we do is that in business process management, you need to focus on three perspectives: the control flow perspective, what's need to be done and when. So basically you focus on predecessor and successor relationship among activities and events. And this is the central information that you depict in a process model. Then you focus on the data perspective. What do we need to work on? So you focus on the input-output data to activities, and this is a very important complement to the control flow. And then you focus on the resource perspectives. Who is doing the work? So what are the human participants or the software participants that perform the control flow activities? And again, this complements the control flow. So what is process modeling? Process modeling is a way of having a language for naming and framing an issue in order to integrate the processes with other artifacts, and this allows you to go through the process to validate and test it, as an example via simulation, can be used as a benchmark for measuring the improvements of your company in order to do what-if analysis, and in general provides a blueprint for process automation. Because if you want to support now your process with the digital technology and moving from the paper, pens and paper, to something more efficient, you need for sure starting by modeling the process that your organization work on. And so why you need to process model? Because this is the real value, is becoming the main asset that the company are interested together. Because it's the knowledge that the company has on how they work, and the way knowing how you work is fundamental in order to improve yourself and to stay on the market. So typically in current organization, the companies are starting to have dedicated management of process. There are units that focus only on modeling and reasoning about process. On the other side, there are many other organizations that are not able to extract the process in order from the complexity of how they work. It's like to say that they are a big mess. They work because they work. No one knows exactly why they do something. And in that case, it's very important that you are able to reconstruct a posteriori how the organization works. And here is, Francesco will tell you, but you also anticipated this morning, is where process mining helps. Because each time that you are not working top down, but in which you are in front of something in which it works, but you do not know why, and you have to admit that this happens very often in the reality, in that case you have to reconstruct the process model a posteriori, and this is why you do process mining. So, what is the life cycle of a process? So why typically the life cycle of a process consists of 5 steps, let's say more precisely 6 steps, but 2 of them are alternative. You start in a top-down fashion. What you do is that you start from a process identification. So imagine that you are a new organization, someone understands that there is a process in order to provide the service, to produce an artifact, whatever, you need to set up a process, and you do process identification. This is done typically with different techniques like specific tabular approaches, or if you are a company already working, you do via process discovery. That is not the case. It was one of the technologies that this morning was mentioned in process mining, and Francesco will repeat afterwards. In any case, or you start top down with the process identification, or you start by mining from the existent. What you do is that you should have an as-is process model. So you need the process of how the organization is working today, because if you want to design a new way of working, you need to start from the as-is. Notably, in such organization that they have hundreds of processes, the set of all the as-is process models is called the process architecture. So the process architecture, let's say, is the conceptual framework that describes in a unique way all the processes that your organization carries out in order to do the business that is intended to do. After that you have described the as-is process model, you need to start a process analysis. So you need to have insight on what are the weaknesses of the process, what are the possible impact of these weaknesses on your business, why do you want to improve your process? Because the question, as I remember that this morning, the citation of Van der Haas is, why do you want to do something? Is the important question that every engineer should do on itself. There are techniques, we cannot go into every details, in which you can have a qualitative analysis, you can have a quantitative analysis, you can have simulation approaches. It's called digital twins are an example. There are technologies that are called digital twins for business process, in which you simulate the way of working of your organization via digital twin in order to understand if your organization has to improve the process. At that point, you do a process redesign. So you need to invent, this is the creative step, let me say, in which you have to invent a new process. And this produces the to-be process model that hopefully will be a model different from the as-is, otherwise there would be no improvement. Then, of course, you need to implement your process. So you need to build the technology that will execute the new process. You derive what is called an executable process model, so a description of the process that can really go on top of software system, IoT-based system, digital system, and it's not stop here, because it's the good approach is not that you implement the new process and forget about it. You need to set up a continuous monitoring and control of the performances of your process, of the new process, in order to verify if the insights are conformant with what you were assuming when you did the design. And if again something is not good, you start again. You over and over go in this continuous improvement cycle in order to continuously improve the way you are working. This is the life cycle of BPM. So the way of schematizing is a model itself, you see, is a model of BPM in which describe you all the aspects that BPM is about. There are research focused on process identification, on process discovery, on analysis, redesign, how to implement, monitoring, and so on. Okay? I go very quickly. My idea is to make you hungry with the BPM. There are typically two approaches when you want to start BPM. These are organizational theory. That is the idea of putting in place a continuous process improvement approach, or others that say, let's go for business process engineering, called BPR, in which you throw away all your process and to start again. Just except in case of revolution, let me say, in which you really have the opportunity to completely forget an organization and rebuild, the most of the practice is done in continuous process improvement. The people starts gradually to put in place an approach like the one that I have previously mentioned, and in this way they start improving their process over and over. And how do you do typically? As I said, you do starting from the process identification, you go in the discovery, in the analysis, in redesign, implementation, and modeling control. And in doing this, you use two types of technologies. The so-called process modeling tools, that are those tools that will allow you to build the models. In a way, you can say that a process mining tool is a subclass of those tools, because in the end, it helps you to build a model. The interesting is that it builds the model by mining the model, not no one design it from scratch, as it happens with a traditional tool. And then you have the technologies that goes around times, that are the process management system. So those systems, those information systems that then are really in charge of carrying out the system. There will be a mixture of web service technology, scheduler, IoT devices, a lot of technologies. They are really suite that helps on this. I will leave for you the details on there are mentioned many techniques that I think it will be interesting if you have to engage an opportunity like this to consider. What I want to go on is to present a classification of the, not to present, to give you the hints on the market that is about business process execution engines. If you go to the links that is mentioned in the slides, and this is the PDF that you can download, you can see that the market currently offers about 20 different technological tools in order to do this. The figure is too small for you, but we'll see that there are products from Oracle, products from IBM, products from Bizzaggi, from Camunda, that are also tools that you mentioned, was mentioned this morning, and there are all technologies that are in charge of executing processing and mining process. But the question is, okay, these are the tools, but when we know engineering, we need to have how to tell instruction to those tools. So the question is that how do you build the models that the tool then will put in execution in order to execute the process? And this is why the modeling, again, is important. And you do this with the BPMN, Business Process Modeling Notation. That is a OMG standard. OMG is the Object Management Group. Probably you heard about, because are those ones that standardized 20 years ago CORBA, that more recently standardized UML, Unified Modeling Language, that more recently standardized SysML, that is the standard language for system engineering. They standardized EDIFACT, if I don't remember badly. So many standards that you, as computer engineer, computer scientists, are standards from OMG. If you want, you can say that OMG is the same as W3C is for the World Wide Web. Is the guy that makes every standards. BPMN is the OMG standard for representing business process. And there are many tools for designing a process. One of them that I suggest you to use it is bpmn.io. That is a very nice open tool on the web that allow you to draw BPMN models, and you save on your desktop, and we use, for example, in teaching or in small projects. What is the objective of BPMN? Is to have a notation, standards that is understandable by all business users, and at the same time is understandable by those guys that do the process implementation. So the standards is graphical so that the business guy can understand, but is also formally grounded to a semantics, like so that we computer scientists and computer engineer can really make system out of it. BPMN started from the Workflow Management Coalition in the first version that was called the VPDL, a Workflow Process Definition Language, dates back to the 95, And currently, in 2010, it was produced the version of BPMN 2.0, that is the one that is currently on standard. So now it's quite mature, because after an evolution of more than 25 years, the last version is there since 10 years. And is really the de facto standard for business process management. Just to give an hint, because maybe some of you were knowing the previous version that was quite famous, that was the BPMN 1.2, the importance of BPMN 2.0 is that you can directly execute a BPMN 0.0 model on top of a process engine that is coherent with those standards. Conversely, previous version of BPMN needed to be converted to some orchestration language like WS-BPEL in order to be used. Those of you that are fluent with service-oriented architecture will know what WS-BPEL is. I will skip, but I will leave you the slides so that you have an hands-on reference on BPMN. In the end, the core of BPMN is these slides, in which you have to remember 4 symbols: the circle, the rectangle, the diamond, and the arrow. And with those symbols and a few others, you are able to draw your diagrams. Why the symbols seems you very simple? Because the idea is that BPMN you are able to draw with the pen and pencil, with the pencil and paper, when you are, for example, at a business meeting in which you are doing the requirements collection of your organization and you need to sketch up the process very quickly. So all the BPMN is taught in order to be with the precise semantics, but also to be simple to be drawn directly with pen and paper without any sophisticated tools. And I assure you that it's very helpful in many meetings to use it in order to describe. When I am at the faculty meeting, just to make you an example, if sometimes there is a misunderstanding on how to proceed on some political issue, what I do is that I draw a BPMN process to everyone in order to say, okay, let's do this, this, and this way. And I can assure that this is very effective. Getting forward, I will now skip slides, but not because they are not important. I wanted to give an introduction, but I wanted explicitly to give you my slides so that you have an hands-on reference to all discussed in case you will need to draw or to get fluent with BPMN. I want to focus on the rest of the story before giving the floor to Francesco for his talk. So I want to focus, okay, once that, assume that we have draw our BPMN diagram of my organization. Now, how do I automate by business process? And so I want to focus on the part that many often is neglected in courses, that is how to automate business process. And in order to do this, I will provide as a side effect, is free for you, a short introduction of what is called enterprise application integration, and also a personal view of what is the making sense of web services and processes. So there is a lot of hype on web services and how to make sense. So just to make very quickly, I just have to tell you that the technology that today we call process management system, until 15 years ago was called the workflow management systems. Because the idea it was what is the difference with the terms workflow? I tell you because sometimes in the advertisement of products you will see still this terminology. You have a workflow every time that your type of resources is only human. So in the current world in which we have IoT technology and software, in particular web service, workflow is just a subset of the product that you may use, because typically you don't want that each step of the process is implemented by a human, maybe via some graphical user interface, but you want that maybe is represented in a software. And so how do you represent a software? First of all, when you have a when you have a work in the workflow terminology, what you could have is that you needed a graphical user interface in order to allow a human user to execute a step of the process. When you interact with this graphical user interface, imagine you as a student, each time that you book your exam on the information system of your university, each time that you fill in a form, in the 99.99% of your time, what you are doing, you are interacting with the graphical user interface of a workflow, because you are booking for apologize. You're booking for an exam at the university. Indeed, this part of the process is the process of learning, for example, is the process that you book the exams, I set up the exams, I book the room in order to take the exams, I register your marks, we repeat this for 25 times because your degree provides that you have 25 exams, and so on. You see, it's a set of activities in order to take a value for someone, you as a student that will have the degree at the end. So in the most of cases, each time that you insert data in a form, you are a process participant that is inserting data into some system. The difference that you have is that in many cases, those applications are standalone. When you adopt a process management approach, what you have is that the graphical user interface and the execution of the logic that is behind this interface is not redone each time ad hoc, but is generated, let me say in this way, looking at the process model in some repository in order to be executed like a scheduler in terms of task of the model. And this is done by the workflow engine, the process engine, if you want to call in modern terms. This engine should invoke application. And so what was the stuff? Until the 2005, the way of invoking those applications was basically ad hoc. So each tool had its own view. And I have these slides to show you. In modern approaches, when you want to invoke an external application, the current technological landscape is that this external application should export the software as a web service. It can be a SOAP web service or it can be a REST web service, but this is the best approach. At this point, you are really model driven because you have a standard that is BPMN to draw the process. And being a standards, you can build tools that are able to interpret, let me say, the standards in order to automate the execution of the process. And when I say to automate, it means that they are able to generate the user interface if the executor of the step of the process is a human, or to invoke a web service as the protocol is a standard in order to make these steps to be executed by a piece of software. And in this way, you pass from the conceptual process model to the executable process model. Marlon Dumas, that is a friend of mine, called this step Atamo, that is, and then a miracle occurs. Because of course, here is where we computer scientists should be able to transform really, according to methods and the deep knowledge of the technology, the conceptual process model into the executable process model. But if you have done really in a good way the process model, what you are doing is that your implementation is documented and is really coherent with what the business analyst have derived. And this is why you are very interested in this part. Okay, so this is the gap that using those type of technology you are able to realize. And I would say that at this point, having given you the entire picture of what is BPM about, I can set up the space for Francesco for talking about process mining, that, as we see, is a very important step of the cycle, because allow you to understand the models if you are not able to draw them from scratch. Are there questions before I move to Francesco? Guys, I don't hear no one.
Massimo, let us proceed, and maybe we can have all the round of
question at the end.
Yes, yes.
Francesco, are you there? Okay, yes, I stop my video.
Of course, yeah.
Okay. Hi, Francesco.
Hi, Andreas. Let me first introduce myself. I'm Francesco Leotta. I am assistant professor here at the Department of Computer Control and Management Engineering of Sapienza University of Rome. My main research activities in the employment of BPM and process mining in smart spaces, including smart homes and smart manufacturing. Now, in this second part of this seminar, what we will look at is process mining. What is basically process mining? Process mining is a term that emerged in 1998. Actually, the concept of process mining is somewhat similar or somewhat already introduced back in 1958, when somebody tried to extract finite state machines from logs. Of course, process mining is different from this kind of approaches, because mining finite state machines is somewhat useless at automating then the process and to visually analyze what the process is. The field of process mining then started really in 2003 with the survey paper from Professor van der Aalst, and since then we have a lot of advancement, a lot of improvements from the point of view of research. Actually, as also discussed in the very interesting paper that we had this morning, the idea of process mining now is starting gathering a lot of interest from industry. And where is process mining? Here, this is the very same cycle, the life cycle that Massimo showed you in the first part of this seminar. Process mining is basically between the point 6 and the point 2, between process monitoring and process discovery. So let's start talking about process discovery. In traditional BPM, process discovery, and in general BPM, is a kind of top-down process, where you start from the description of the process, and then you execute this process. You turn in the end this process into an executable business process. Well, in the vast majority of cases, this simply cannot be done. Companies works on processes that are basically only in the minds of the people that enact this kind of processes, and they are not really available as models. So what process mining does is that it basically confronts the data that is produced by process mining execution systems with process models. That is, it confronts the data that is actually produced by the process with what we expect from the process, from the process itself. Here is a slide about how process models can be represented. Of course, as Massimo said, there are many different formalisms that can be used in order to process a model. In the end, what happened is that from the point of research, process models are usually represented as with formal formalisms, such as Petri nets. Usually, all of the most important graphic formalism for BPM can be, such as BPMN, can be translated into Petrnets. So let's start thinking about what a process management system is in the end. What a process management system does is that basically it allows to execute operation inside the process. And what happens is that while the organization is running its process, what happens is that a kind of log of what happened in the process is produced. Now, the process model that we have at the top of the slides can be something that is already available, or can be something that is actually only behind the knowledge of who is working in an organization, but the process is always there. It can be explicit or it can be implicit, but in the end, what the process management execution system does is to produce a log of what people do while executing a process. And here in these slides, you have several different logs that can be produced by a simple model like the one that you can see in the top part of the slide. So what we start from in process mining is to basically have an event log. An event log is something that is fundamental in process mining. And we may have a process model. Why we may have a process model? Because in some cases we do not really have the process model, but also the process model must be extracted from the event log. So what we have in process mining is always the event log. But in the end, what process mining wants to do is to confront these event logs with the process model. So a process model must be obtained either in a top-down fashion, or in with a bottom-up strategy. So process mining aims at answering this kind of questions. What really happened in the past? Why did it happen? What is likely to happen in the future? So a kind of prediction feature of process mining. When and why do organization and people deviate from the standard expected behavior? How to control a process better, and how to redesign a process to improve its performance. For example, we can find the bottlenecks in our process and act on these bottlenecks in order to remove them. Let's see two different strategies to relate models and log. We will see play-in and replay. Play-in and replay actually basically have a specific term in process mining, where play-in is basically the process discovery, and replay is basically the conformance checking. So in play-in, what we want to do is that we want to start from an event log, and we want to extract the process model that more likely represent this event log. This is something that is a lot investigated in the process mining research community. There are a lot of open issues still, so it is a very open and very challenging research field. Here, as you can see, differently from the slides that we have seen at the beginning, we start from the logs of the different execution of a process, and we want to extract the model that is at the bottom. So basically, what a process discovery algorithm does is to take the event log and to extract a process that is described in some specific kind of formalism. For example, in these slides, you can see the fuzzy mining output formalism. But the idea is that basically you will have a diagram where each of the activity that you can see in the log in the back of the slides is represented by a box in the diagram. So basically you take the log, so you see how the process has been conducted in several different repetitions, and you extract a model of this process. Here in the area of process discovery, there are a lot of algorithms. The very first one was the alpha algorithm, but since then a lot of new algorithms has been proposed in order to face many of the challenges that the original alpha algorithm could not face. For example, incomplete information, missing transitions, parallel branches of the process, etc., etc. Replay is another important aspect of the research in process mining. What replay does is that, given an event log and the process model, it tries to understand how the event log, which is the actual behavior that is seen in the executing system, is conformant to the process model. That is, we want to find whether there are differences between what people do in the reality and what people is expected to do given the model, and to understand if these discrepancies must be somewhat included in the model, or whether they must be signaled as a wrong behavior. Of course, if we have an event log in the process model, we do not only want to understand whether these two things are somewhat different one each other, but we also want to quantify this difference. And this is what conformance checking does. And the goals of conformance checking are different. You can do diagnostic, you can do prediction, you can do recommendations about the model, etc. And essentially, what conformance checking is, here we have a very simple view of what conformance checking is to try to replay the log inside the process model that we have, and to understand whether these two fits. For example, here we have the log ABCD. And we can see that the log ABCD can be reproduced inside the process model. This means that this trace, this execution of the process, is compliant with the original process. The same for the trace AED. The trace AED can be reproduced inside the process model. So it is a conformant trace. Here we see from the system the trace ACD. Well, the trace ACD cannot be reproduced in this model. Here we have a problem called missing token, which is something very related to the formalism here, which are Petri net. But here the idea is that the trace that we have seen in the reality, that the process management execution system stored inside our database, simply cannot be reproduced. This means that there has been an exception, or there has been a deviation from the original process, and we want to analyze which is the reason for this deviation. So here we have slides. This is a very famous slides about process mining, where process mining is. Basically, here we have our world. The world is made up of business processes, of people, of machines, of organizations, and all of these things are controlled by software systems. These software systems can be actually based on a real business process, or in the end, they can allow people to perform some kind of business process with a certain degree of flexibility. But this system produces records. These records are stored inside an event log. And what we want to do is that we want to confront this event log with the process model that we have in the documentation of our organization, or that we want to extract directly from event logs. If we want to extract the process model from the event logs, so what we do is discovery. If we want to confront an existing process model, either done by hand or extracted automatically from data, we do conformance. if we want to use the information in the event logs in order to improve, to enhance our understanding of the real process model, what we do is that we do enhancement. Vast majority of research is focused on discovery and conformance checking, whereas enhancement is a little bit behind as a level of maturity in terms of technology. In particular, we also have other techniques, which are, for example, performance analysis. We want to understand where are the bottlenecks in our process, or prediction. And nowadays there are a lot of different supporting tools for process mining. We have ProM, which is probably the most famous one in the open source scenario. ProM is a tool, it's a plugin based tool. The same for Apromor. These two are basically the two main competitors in the open source scenario. Recently, PM4Py, which is a library for Python, including several different process mining methods, is rising as an interesting open source technology. And then we have a set of commercial tools that are increasingly incorporating techniques from process mining. So let's give a quick look at how an event log is supposed to be. Basically, we have a process. Each event log is associated to a specific process. In the company, we can have, of course, several different processes. And each execution of the process is a trace or a case. So basically, here we see this log that is horizontally divided in cases. Each of these horizontal blocks is an execution of the process. And for each execution of the process, we have all the activities that have been performed while executing this trace. With event IDs, with timestamps, with the name of activity, with the name of the research that performed that particular activity, with the cost of that particular activity, where the cost is something very generic, can be computed in several different ways. And then each trace consists of events. So basically, each trace is a potentially different way of performing a specific process. And each event in each trace has a set of attributes that can be used in order to analyze the process. At minimum, what we have for each event is an activity name and a case ID, but usually also a timestamp is available. From the point of view of research, then an event log is represented as a multi-set of traces. Why a multi-set? Because each of the different traces can appear at different times in our event log. For example, the trace ABCD is here reproduced 3 times, ACBD is reproduced 2 times, and AED is reproduced once in the log. And in order to represent logs, there is an international standard, which is the extensible event stream, which is an extension of MXML, which is the previous standard. XCS is an XML-based format, and here we have a schema. Basically, the format of an event log in XCS is the one that you can see here. You have a log. The log is divided in traces. A trace is divided in events, and for each of these components, the entire log, the trace, and the event, we can have attributes and different classifiers. And it's also possible to create extension of the XCS meta schema. So let's start from the challenges that we have. We have seen that process discovery is one of the tasks in process mining, where we want to extract a process model from an event log. What we do with process discovery is that we take the log and we create a model using the several different formalisms. In the vast majority of cases, this formalism, the chosen formalism is Petrinet, which is a kind of universal language in process mining. Now, what we have is that the model that we extract to process discovery can or cannot represent very well the process according to the characteristics, the real process according to the characteristics of the event log. In particular, the event log may be subject to noise and incompleteness. What is noise? Noise are, of course, executions that should not be in the process, but that have been exceptional cases where, for example, the process was conducted in the wrong way. For example, during an execution of a process, one specific check, which is actually mandatory, has been skipped. Or the event log can be incomplete. That is, what we have seen in the reality does not represent all the possible execution of the process. And of course, these two kind of things are very difficult to face. And in particular, basically, when we obtain a model from process discovery, we can measure the quality of this model by using 4 different measures, which are fitness, precision, generalization, and simplicity. Actually, these are the most famous metrics. There are much more metrics. So what we can see here is that basically in the left part of the slides, in the solid line, we see the traces in the event log. The traces in the event log are the dots. The frequent behavior are the ones that are included in the solid line, whereas all the behaviors that we have seen in the log is the one in dashed line. Let's say that the target model is the one in the solid line. That is, the frequent behavior actually describe what is the real model. At this point, once we have an event log and the model that we extracted from the event log, we can compute the fitness. What is fitness? Fitness is the ability of the log to reproduce, of the model to reproduce all the traces that we have seen in the event log. The precision is somewhat similar to fitness in the sense that it describes how well basically the model that we obtain describe the event log. Generalization is the ability of the log of the model to also cope with traces that we were not able to see inside the event logs. And the simplicity, following the Occam-Razor principle, is basically the idea is that a simpler model is better than a more complex model in order to describe a specific thing. At this point, what are the things that are interesting for companies when they use process mining? Diagnostic, of course. Diagnostic allows to understand whether the event log is actually compliant with the process, and to understand whether there are some kind of bottlenecks. Of course, when we compare the event log and the process model, and we see non-conformance, we can basically interpret non-conformance in 2 different ways. If the model is intended to be descriptive, and this is the case, for example, when a model is only available for documentation, or when the model has been discovered from data. When we see non-conformance, maybe what we want to do is that we want to improve the model. In some other cases, instead, the model is normative. That is, we have a model that we must respect. And in this case, we must understand why deviations happen, and we decide whether to fix this kind of deviation or in somewhat to avoid that this kind of deviation happens in the future. Of course, the normative part is also connected to some regulatory board, such as the ISO specification. And in some cases, what we want to do with process mining is also to provide a tool, for example, for auditing. That is, we must ensure some kind of regulatory organization that we are respecting some kind of process. And what we do is that we ensure these things by showing the results, for example, of conformance checking. So process mining opens the way to new strategies for auditing. So to conclude the talk, I hope we are in time. We are a little bit out of time. So process mining is the innovative wave of business process management, and of course allows for several different things that can be helpful in an organization. Of course, the tools that we have in process mining are not something that can be applied directly. They are not really generic, but they must be customized with respect to the specific use case. So in order to apply these kind of things, you need to study actually the business case, to analyze what is the granularity of the available logs, to perform some kind of data cleaning of the log that you have. And of course, the methodologies that you have are still not perfect. They have defects, and I mean, the main goal of research is to resolve this kind of defects. Anyway, process mining represents nowadays a tool that can be that company can really start to use for their business. So this concludes our seminar. Any questions on the first part of the seminar or on the second part of the seminar?
Thank you, Francesco and Massimo. Any questions from the audience? Okay, I have a question, a comment-like question. You talked about non-conformance, right? I think there is a thin line between discovering a real deviation between the process that should be followed by the company, but instead it follows something else, and this is dictated by the logs. And the situation in which you fail to capture the real, let's say, recorded process in the logs. So I assume that there is a couple, or I don't know, some metrics to enable the modeler to define whether it's the first case or the second. I mean, there must be some metrics that can identify whether there is non-conformance in terms of different business process, actual versus desire, or there is non-conformance that is the result of poor logs or poor modeling attempt. Is this right, or is there we do not have such tools?
This is actually a definitely correct observation. The point is that actually the only things that the available metrics allows you to do is to confront basically the log with the model, and to give some kind of quality measure of the model. But the quality measure of the model is not something semantic. Are metrics that basically follow, as I said before, the Occam razor. So if your question is whether there is a principled way to differentiate between actually a deviation that really is there and the poor quality of the event log and the process model, there is, at the best of my knowledge, there isn't anything like this. It's something that is always given to the human expert. To the human expert, you say you have this deviation, and the human expert tries to understand that. Because the vast majority of methods actually works on statistical things. So they basically, the assumption is that if I see something once, probably it's a random deviation that will not happen in the past. If instead something is frequent, probably it is correct.
Okay. So do you think there is room for somehow standardizing at least the angles, the perspectives under which you can evaluate, at least assess, not evaluate in precise terms, the whole process of discovering the model, so as to be alarmed if the whole approach you used is suffering from some flaws, or for example, the logs are not so representative, then you should be alert that, okay, you should dig in more, you should discover, for example, more accurate or more unbiased logs, or maybe talk to the company to see whether there are exceptions of some processing steps, so that these cannot be considered actually as outliers, but as a deviation from the normal process. So do you think that there is room, and by room I mean it's feasible to try?
You mean a process to evaluate the process, actually?
Exactly.
I would define a methodology, a precise methodology.
Exactly, and to include, for example, the statistical approach to this may be enhanced by fuzzy logic, by machine learning, and so on. But at the end of the day, this will be just indications and not, for example, prove something. But it will be better than the non-existent, let's say, framework that we have now. We do not have now.
Okay, sorry, Massimo, then you can say if you know something. At the best of my knowledge, there are solutions for specific aspects. For example, Andrea, which gave a seminar in the context of the Destini project, for example, worked on give suggestion about GDPR respect in a process model. But not something generic, at the best of my knowledge. Massimo, what were you saying?
No, there is nothing generic. There is no current methodology. I think that the effort is worthy, but I make this metaphor. Once upon a time, there were databases. Then the people needed 20 or 30 years of practice before deriving a general purpose methodology that is probably what is taught in every course, is that say starts with the conceptual model, then build the logic model, then build the physical model, and we have all the guidelines on how to do it, and is what is taught in every course in databases. So what Andreas is asking is the same, but we are 40 years later. So what I mean, process mining is really in the infancy, despite the fact that there are tools. We can say that the people are practicing with process mining since at most 10 years, at most. Okay. Also the research. So we will get to a general purpose methodology, but in my opinion, they will need other 10 years for this.
Anyway, I find it very interesting. We should.
No, it's very interesting.
We should reason about this.
Because in my humble opinion, to start modeling something based on the wrong, let's say, assumption or the wrong basis, then you are definitely going to lead to producing wrong results. So yeah. Any conformance checking, any optimization, any improvements, and so on, will not be, let's say, reliable. Okay, so the step number 0 could be, before starting, I mean, to exploiting data logs, is to find a way to characterize the accuracy of the logs, not in terms of missing values or outliers and so on, but whether these logs have some properties. I don't know which these properties may be, but some way to assess the quality of the logs, not in terms of completeness, but in terms of accuracy of the process that should be followed. I don't know if this makes sense. I'm just thinking aloud.
No, it makes sense. I think that we need to investigate a lot.
Yes.
So it's a very open research, I would say. So
okay. Thank you, guys. Any other question from the audience? Someone wishes to add something, comment, ask? No? Okay. I guess, Stelios, this is the last presentation for today. Please correct me if I'm wrong. Okay. So I would like to thank you all for your participation. Many thanks to Massimo and Francesco for the interesting presentation. It always brings up new ideas and new challenges to address. So we are going to talk again about this in later meetings. So if no one else has nothing to add, I would like to close officially this day and welcome you tomorrow for our last day of the school. So thank you very much all. Take care.
Ciao, thanks Andreas. Ciao all, have a good lunch.
Thanks Andrea.
Thank you, you too.
For the organization.
Thank you, bye-bye.